Guys, I am super stoked to have you here. Welcome to the Lifestylist Podcast.
Hey, thanks for having us.
Good afternoon.
Yeah, I was texting a friend of mine today, and I said, man, I'm so excited for this interview. I feel like a 14-year-old at a Justin Bieber meet and greet. I think I texted you that or something. Yeah, I texted a couple people. I'm like, I'm so excited. I mean, I interview some really famous people in health and wellness and meditation teachers and the like, and I get excited for those. But since meeting you guys that couple weeks ago and sitting down for what I think was a 3-hour conversation about deuterium, which we're going to cover today, I've been obsessed with this topic. I've watched all of Laszlo's videos that I could find online. There's 2 or 3 of them. I watched one of you 3 with Ann. I mean, I'm diving in. I'm searching iTunes for the podcast. I'm happy to say there aren't really any podcasts out there covering deuterium in a meaningful way, so I feel like I'm the first one to the party here. But I'm really excited, and I think that this is just such an important time right now in health. I don't want to go so far as to say we've discovered penicillin here and I'm reporting on it, but it's pretty intense based on our conversation. Very powerful information. So thank you for joining me. I'm really excited to dive in here. So let's start out just with a brief introduction of who each of you gentlemen are.
My name is Laszlo Boros. I finished medical school in 1987 in Szeged, Hungary. And I came to the United States in 1990, started at Ohio State University, Department of Surgery, and then I got my faculty position at the University of California, Los Angeles, UCLA. And I'm a full professor of pediatrics at UCLA, and I also do advisory work for the Center of Deuterium Depletion centers. I do editorial work, paper reviews, and teach biochemistry, deuterium chemistry, and medical implications and translational medicine, how deuterium biochemistry would open our knowledge base towards some basic biochemical and medical problems in that sense.
Awesome. I understood some of that.
Yeah,
it's interesting. I always call you Dr. Boros, but when you pronounce it in your native tongue, it's more like Boros.
Boros is the Hungarian pronunciation, and but they called me everything else already in the U.S.
Myself, I understand.
Don't worry.
All right, and then Q, tell us who you are. We're going to read your guys' bio and the intro and stuff, but I also just like to get it from the horse's mouth.
Well, I am Q Collins. I'm a clinical immunologist, have a PhD, graduated with a PhD in the late 80s. Also have a master's in cancer epidemiology and a master's in oncotherapeutics. Worked on for a couple of pharmaceutical companies in my past life, and probably for the last 7 or 8 years have been focused on using both standard of care and natural, using both diet and now deuterium depletion to integrate those things. And I'm focused almost solely and purely on cancer research.
Cool. We need it. Every time I see one of these little pink pins or bows or whatever, I'm like, you guys, we already have cures. It's called prevention. Anyway, but we'll get into that. So, obviously the focus of this is going to be something that a lot of people have not heard of. And based on my first conversation with you and our third party, Ann, who's our sort of our silent partner here, just because we didn't have enough microphones to make her part of the conversation, but she was in fact part of our original conversation. And it sort of was like this to me as the fourth participant in that convo. It's like Laszlo would say something, then you would kind of translate it into common English, and I would understand a little bit more of it then, and then Ann would kind of break down the two of you, and by the end of it, I go, oh, okay, I get it now. So we're gonna come at this from a deeply scientific level, because I do have listeners that they're like, I want the data, I want the science, this has to be real and provable, otherwise my linear brain doesn't believe it. So we're gonna do a bit of that. And I also want people to walk away by the end of this conversation and just go, oh, I get this. This is actually not that complicated. So let's hear from each of your perspectives. What is this thing called deuterium that builds up in our bodies and ends up causing us problems if there's too much of it for too long?
Yeah, so deuterium is a stable isotope. It's the isotope, stable isotope of hydrogen. And it's actually the heaviest isotope in comparison of its isotopic pair, hydrogen, because it's twice as heavy. And for that reason, hydrogen, which is the smallest atom that participates in biochemical and biological reactions, in particular, it actually generates energy in our cells. A twice as heavy kind of twin brother or a twice as heavy companion that participates in the same chemical reactions and in the same energy producing reactions is not very desirable, simply because it breaks proteins, it has different affinity to various chemical bonds, and it behaves differently, vastly differently in biological systems. So as deuterium, and this is where the name comes from, it's twice as heavy as hydrogen. It actually breaks biological systems, cause disease, and induce a lot of non-physiological reactions in any living organism. And we know, besides carbons and oxygen and hydrogen, which actually make up 99.9% of all living organisms, hydrogen is the most mobile or the most reactive that participates in many biochemical and physiological reactions, and deuterium breaks those systems and mechanisms. So this is why we need to keep it under control. Now, our biochemical systems or our physiological systems have mechanisms to actually control deuterium to a certain environmental threshold, but we exceeded that now. And we believe that this environmental factor, which is a heavy stable isotope of hydrogen, cause a number of population diseases, including cancer, obesity, diabetes, and early aging, neurodegenerative conditions, and so on. Almost every population disease process would be affected by deuterium concentrations and levels in the environment. So this is our basic goal, is to understand the mechanisms and learn how to deplete or get rid of deuterium from our bodies, and how to use this therapeutically, and how to teach this to generations to come of how to control deuterium from the environment and how much of it can get into our body.
So unlike a toxin, say, a lead or something like that we don't want in our body, heavy metals or some sort of other contaminant that's in our environment, deuterium is natural. It just exists in our atmosphere, in water, in earth, in plants, in animals, in stuff. Is the issue that because we've polluted, the planet so much in industrialization, that there's just too much of it accumulates in us through the course of our life, so that we pass this threshold where we can't get rid of it ourselves?
So two things, it's not a toxin, like you said, and it's really interesting because, again, what we actually just are about to publish a little a blog on it, but Laszlo was going through a couple of papers a couple of weeks ago, and what we found was about 20,000 years ago, the actual deuterium levels on the planet were 10 to 15 parts per million lower.
Ooh, interesting.
So it's very interesting because, again, back then you didn't have all of these cancers and diabetes. People lived a lot longer, contrary to what they lived a lot longer. The Bible says, 600, 700 years. Believe that or not believe it. But biologically, it makes sense because even bacteria and viruses wouldn't have been big back then. So it is so if normal level's lower, but it was low enough for our bodies to be able to deplete it. Now, the deuterium is important because it is actually something that our body needs during certain parts of our lives. So when we're babies, when we're young, when we're growing, deuterium is a molecule that is required for that fast growth. It's just as we age out of that, it's no longer necessary, right? Instead of growing up, we grow fat. And that, and we grow
Right.
cancer, we grow diabetes.
We
is
grow
what I look
stuff
at.
we don't want to
We
grow.
grow stuff we don't want to.
And so, say I was living 10,000 years ago, pre-agriculture, pre-industry, I would have had a certain amount of deuterium in me as my body's growing. But then, as I stop growing through, my late teens, then my body goes, okay, we don't need this isotope anymore, and it starts to deplete it on its own. But now there's just so much coming at us in the water and the food and environment that we reach this certain point and we just can't get rid of it. Is that the basic idea?
Yeah, both, and Laszlo can cover it even better than I can. Not only both that there's so much more in the atmosphere, there's so much more around us, but also those depletion mechanisms that we know about, we don't do anymore. We don't sleep well. We don't exercise the right way, not the exercising 3 hours a day, which our ancestors didn't do. Doesn't make a lot of sense, but we don't exercise the way we need to. We don't breathe correctly. All of these are deuterium depletion mechanisms, which are the ones that we know that are most profound. There may be other smaller ones, but yeah, we're screwed both ways.
So because we've become so kind of disconnected from not only the natural environment that doesn't exist anymore, but just our life way and our behavior in terms of how we breathe, how we move, how we interact with nature has actually changed and gotten pathological in a sense.
Yeah.
Like right as you said that, I go, I've been holding my breath for the past 15 minutes that we've been talking. Right as you said, I was like, oh yeah, breathe, Luke. And I'm someone who does a lot of breath work and yoga and all this stuff, and I still sometimes find myself breathing shallow, where if I was out in the plains 10,000 years ago hunting caribou or some shit, I'd probably be just breathing like a maniac,
Yeah, it is interesting because, again, Laszlo always likes to say, you take oxygen, you take hydrogen, you make water. It's that simple, right?
Right.
And that's what helps make energy. All these things are together. So if one thing's missing or one thing's wrong, it messes up the end thing, which you can talk about that.
I have one quick question before I forget, because you mentioned as we're growing we need deuterium. If a woman is pregnant and her threshold is super high right now, and we'll talk about the different numbers, parts per million, is her offspring automatically going to adopt her levels and be born with too much of it also?
Well, we don't know how much of deuterium pass the placenta. So we don't know what is the normal deuterium level for babies or newborns. And I would assume there is biological gating mechanisms, which there are, we know, in cells and cell compartments. They actually try to keep deuterium out. So it may be the case, yet again, there's in many areas of medicine where we have to generate still data. But it would be interesting to see, obviously, what is the deuterium distribution between mother and the grown babies. We do know that the fast growth of babies doubling, tripling their body weight in the first year of their lives may very well depend on deuterium, simply. So we believe that through our lifetime and through our growing course of our life is practically deuterium is a very important environmental factor, and our body utilizes it differently, and it utilizes it for different purposes. As Dr. Q said, it's actually over a period of time when we have to control for population diseases, deuterium may become very harmful, simply because, and I'm just going to reflect back to your question, caveman's time, just 15, 20,000 years ago, caveman's time, the vapor of the ocean had about 10 ppm or parts per million less deuterium than the vapor of the ocean has now. Now, if that's where deuterium environmental concentration has started as a baseline, then all the biological fauna and all the biological systems could deplete it very efficiently to the 115, 100 range, which our body and our society, going back to caveman's time, have adopted to. So practically, because of geochemical and because of global climate change. Now this fractionation factor is higher, meaning that the vapor has higher deuterium, oceanic vapor that waters all our crops and brings rain to the lands. To lands, then it is actually just a very high level that our biological systems are not able to deal with.
When you're talking about the levels in the ocean water that then turns, of course, into clouds and gets in our rivers, streams, lakes, food ultimately, and animals that we're eating if we eat them, does the pollution of the industrial age have anything to do with that? You know, the coal mines that are spewing lead into the ocean, all of that, I'm assuming, is a contributing factor?
Well, two things. Yes, that's one part. So a smaller than, but probably more importantly, because the deuterium levels are higher, energy is lower, our systems aren't working. Now the onslaught of those things are far more harmful. If your deuterium levels were low, you had the energy, pollution wouldn't hurt you as badly as it does. Right. So that's really the way we look at it.
So we're gonna get into. I want to cover like more of what this is. We're gonna get into the depletion protocol and things like that. But on the topic of childbirth, would it behoove a mother who wants to have a kid to do a depletion protocol, then get pregnant?
So this is interesting, and we've had Dr. Cooper, who isn't on camera. We always like she's delivered princes with this with this method. And what I mean by that, we have we're really starting a protocol to where for women, women are having babies older and older and older, and so often they have to spend a lot of money to have those babies. We're having, taking whatever hormones or anything to boost them up, but they still lose them. So what we've been able to do now is to use this deuterium depletion protocol on those women before they get pregnant, and magically they are delivering babies. We just had one delivered last month, and so it's pretty cool. So the answer is amazing. Absolutely yes. And the other thing you asked, which I want to go back and touch on, so what do we think about this? As we said, it's maybe gated out in women, but what we do know anecdotally in epidemiological studies is that we do know there are younger and younger disease. There are more babies that are having diseases earlier, and there are a lot more babies that are dying from sudden infant syndrome. For instance, especially I talked to the Ohio Congress 2 years ago about this, and one of the things we were doing to combat that was using a deuterium depleted diet, using that on mothers who were not only before they were going to get pregnant and during the time they were going to get pregnant, to try to decrease SIDS and decrease things like that. The data's not back, and Ohio ultimately didn't put as much into it as I would have hoped, but we do believe that ultimately, there's enough anecdotal out there that, it does help. We believe it's because of the deuterium depletion and not because of the simple diet change. So, on both sides, women, especially if they're older, should definitely do a deuterium depletion before and during their pregnancy.
That's cool. That's really good to know. I think it's so sad when people have kids and the kids develop these problems early on. It's just, or that they can't conceive in the first place. And I just know, or at least I intuit, that it has so much to do with the toxic load in the environment and not having that, the woman in the optimal health, and even the man for that matter, before, to bring that baby in. And I always think, when and if it ever comes time for me to have a baby, I feel sorry for my future wife, because I'm going to be like, you got to do this. I'm going to put her through like a 5-year program of protocol to get, the vessel prepared to bring in Luke 2 or Lucia, however it might go. So that's interesting. So when we talk about the levels in parts per million, to me, if you're talking about a level below the threshold of 130, which I'll get you guys to explain, and if I'm 135 versus 130, who cares? Like, how much does each point matter in parts per million with deuterium in your tissues or in your body? is it almost logarithmic? Does it add up exponentially like that, where 10 points is huge, as you said in our environment, Laszlo, that there's 10 parts per million more now than there would have been prehistorically, and that's a really big deal. It's meaningful. So how do the numbers work in terms of parts per million?
Well, basic physics states that parts per million is practically how many of deuterium we have of a million hydrogen. So by definition, parts per million means that 1 million hydrogen atoms in the environment in any form, in water or just hydrogen gas, whatever it is, it has 155 deuterium isotopes. That's why it's 155 ppm. Parts per million means of a million entities, how many is of what we are naming.
Okay.
So that's why it's called ppm,
and
or
would that
parts
be the
per million.
same when I go out and collect spring water? As you guys know, I'm a spring water fanatic. I've been collecting it all over not the world, but all over the country. And I always have a TDS meter because I'm looking for that really low mineral content. When I find a spring that's super cold and a low TDS, I'm stoked. So my water now, I think, is around 60 total dissolved solids. That's different than a parts per million.
That's right.
Right?
Yet you can measure your ions or whatever solvents there are in water as parts per million, meaning that it's a very general terms in
on the
physics.
Back of like a Mountain Valley water, it says TDS 220 ppm.
ppm, yeah.
Okay.
So it would tell you of any particle, of all the particles, how many is what you're looking for. Right. So they count them all. They count out 1 million, and they tell you how many of those million are zinc or potassium or sodium, whatever ions or contaminants there are in there. You can always tell of how they are distributed among different entities. You just look at 1 million particles.
Got it.
So it's the same with deuterium. Practically, you just count the hydrogens and you tell, after all, how many deuteriums you found. Now, looking at this number is it's a set point. It's really not. You can't really tell if it's too much or too low. It's a biological set point. It's like your temperature. Your normal body temperature is between 36.5 and 37 Celsius. If it's 37.1, then something is wrong. So, this biological trash, it doesn't mean that it has to increase by large. It just has to be different from the set point by some, and that indicates disease.
And why is the critical number in the human body, according to my conversation with you guys last time, 130? Why is that the threshold that we're trying to get under, at least as a starting point?
So it's that threshold is where there's two reasons. One, that's really what we see in green plants, like 130 and 130 and below. So we know this is the natural thing that exists out there. But what we've also seen clinically or anecdotally in the clinic is that as we get you below 130, your body seems to be able to start taking over, and it keeps lowering it. And then you start to see your own ability to deplete deuterium without supplementation kick back on. And you also start to see all those things, inflammation or depression and all those disease markers to start to mitigate themselves and disappear. So that's why.
I think when I talked to you, you said you got yours down into the 90s or something.
Yeah, that was hard, man. Well, this guy, he operates there all the time. But yeah, I got mine dropped down into the 90s. It was and I'm an old guy, so that's tough. As you get older, your ability to deplete deuterium goes down, and you just don't have as much margin to do these kind of things. So I was proud of myself, but yeah. Now,
what's the height? You guys, how long have you been doing this testing that you guys do?
Well, we've been doing. Laszlo's been at this for a long time. We invented the test really over the last 3 years, and that's been the biggest thing of how we've been able to move forward this whole science and this understanding is by creating tests for all the biological fluids, whether they're urine or saliva or tears or anything like that. And then this last one where we've now been able to look at it for a marker, for a tissue marker. And then Laszlo has recently came with using the MRI to be able to see that deuterium cloud throughout the body. So that's been the biggest step of all things. So now we've made this clinically relevant where people can't argue against it.
I love that because I just love testing. That's one of the things I really dig about functional medicine. I work with a company here called Parsley Health, who I'm actually working on introducing you guys to. They're great people. And one thing I really like about functional medicine is you have, as a patient, you have so much more autonomy, and you have so much more license over the tests that you want, and then having a professional who's educated tell you what they mean. And I really look forward to this protocol, this testing, just being implemented as something you do. I check my hormones, do the heavy metal, urine challenge test, the hair heavy metals, all the tests that you do in functional medicine, that this just becomes one of them. Yeah. It just is seems like a no-brainer.
You should check your deuterium first, go below 130 and check the rest of them again.
Oh, okay, why is that?
Because we believe that your biological comfort zone, your set point, is below 120, depending on your body compartments that you're looking at. If you're above that, it may cause a number of problems that show up as hormone abnormalities or disease symptoms or laboratory results that are abnormal. We think that a lot of those can be fixed first by the appropriate deuterium depletion protocol that includes diet and what type of water and what type of lifestyle anyone is pursuing. And then your lab results would turn out dramatically different.
What'd be interesting is to do all your functional medicine labs, don't do anything else but the deuterium, to get the testing, then do the protocol, then go back and do all your seemingly quote-unquote unrelated labs after.
That's what I recommend to, patients who ask me what to do. I tell them right now, you don't have to do anything. You need to deplete your deuterium, and then we'll go back to your original problem if you come back. But usually they don't come back. So
you lose. It's
ours is probably the worst business model. So
you don't want to lose customers. Yeah. So in terms of, I want to get my head around these numbers because I think that's going to be important for people to understand. So since you've been doing the testing or just anything you've heard in this niche industry, what's the highest number you've ever heard of for someone who just severely ill, suffering from some disease?
So let's talk about our own numbers because we don't. I don't like to talk about anybody. Others, it's just so my highest was, and you can talk about, those were in the range of 145 ppm from me personally, and from my breath, which is the more like my body's deuterium content, my cells. It was kind of a marker of it. It was about 135. So. Considering my age and my diet back then, it had to be lowered, obviously. So then you would, try to consume deuterium depleted diets and drink some. I don't drink water, but there's many ways of depleting deuterium very efficiently. But there are, again, very important biological markers, how fast your nails are growing, how fast your hair is growing. So you can tell just by looking at your own biological functions of what is your deuterium kind of in a ballpark.
Yeah, and we have seen certain things. Again, we don't like to talk about the specific number. What we see is when it's above 150, up to 155, just like ocean water, then we see that very rarely, but that's usually associated with people that have a metabolic issue.
Right.
Okay, we don't know if it's diagnostic. We haven't done nearly enough to do that or trying to validate it. It's just interesting anecdotal information to the point that the highest ones we've seen, they have not been with us much longer.
I see.
And
so have you ever seen a really high number in someone and they're perfectly healthy and have tons of energy and feel amazing? I'm at 150. I'm rocking it.
No.
Not happened yet? Okay.
No.
Okay.
We've seen high deuterium concentrations, and then after all, we figure there's an underlying medical condition.
I see. Okay.
But we never seen high or low deuterium levels without a reason.
Got it. Okay. And then with that number of 130, which Laszlo said is somewhat arbitrary, and there are other factors contributing to that, I don't even remember who told me this, but I've been talking about deuterium so much, all my friends are ready to punch me at this point, since I first met with you guys.
And we appreciate it.
But somewhere along the line, someone said, it was like a meme, or someone just went, Psh. They said, yeah, if your number's under 130, it's impossible to get cancer. Would you say that that's... Where did that come from? Is there any basis of truth to that?
Under 130, your deuterium levels can be low enough to where it'd be very difficult to get cancer. Is 130 it? Probably not.
Okay.
It's lower. What that is, I know Laszlo has a couple of guesses.
It's very relative, because medicine and thinking has to change. You may have cancer below 130, but it's not progressing. You may have all what we consider like oncogenic lifestyle, or whatever you name it. If you change your diet, if you change your lifestyle, you deplete deuterium, just to be more specific, then the course of your disease, and it's just not cancer, it's your obesity, your diabetes, your type 1, type 2 diabetes, your medical conditions, if those are not very advanced. Again, we are not magicians, we are biochemists and doctors, so we do very thorough processes as far as publications go, as far as peer review go, as far as generating and interpreting data. And we talk about these scenarios with colleagues and doctors and physicians who treat patients, and we hand this information to them, just what to look for. Simply, we treat many different diseases from the deuterium point of view, but it's not necessarily just and only cancer or cancerous phenotypes. We are actually dealing with a number of other conditions, all of them practically, I would say. And we found that deuterium measurements and deuterium depletion is very important as far as the cure or therapeutic approaches go. And it affects standard therapies, how efficient they are. And it affects drug dosing, whatever is necessary for the patient. And there are many different aspects or many different translational use of this type of information and the data we generate, because we measure, as Dr. Collins was saying, we measure deuterium in body fluids and in breath, in exhaled vapor from patients' lungs. And this is what it leads to, definite numbers that we can relate to disease processes.
Not only disease process, because people always think this is only for being sick, but it's not. We actually also use the same techniques for athletes and for some of the best athletes in the world, gold medalists. So it is simply the way the body works, and if you make it right, you're a better athlete. You make it wrong, you're sick.
Will it make me run faster?
Yes. No. It allows you to train harder and recover faster.
And you could probably jump from the roof like a cat can, meaning that you don't get injured. It's again, you may run faster, but that's not the only benefit from this. Right. So you may just be very creative in that sense, and just whatever problems you might face, you might be able to, control those better with low deuterium concentration.
Speaking of the numbers, I have my test in front of me here that we administered, and I see that we've got one of the breath tests here. I'm gonna get that on camera in a little bit, because right now I don't want to mess up the audio recording, but I definitely want to show that on the YouTube video. So, by the way, those of you listening, I don't know if you're aware of this, but most of the interviews that I do are produced and edited for a really nice, clean YouTube video, so you can find it there. And if you follow me on Instagram, at Luke Story, I do just about every interview live, and you can see the behind the scenes of a conversation just like this, as well as in the private Facebook group, the Lifestylist Podcast. So go to Facebook, join the group, and you can watch all of the hijinks that you listeners that are hearing the audio podcast don't get privy to. So back to my numbers. So I just did this test with you guys, which was the breath and saliva test. Q sent me the results via email, and we've got, for the listeners, I'm just going to explain what this report looks like. It's a very simple graphic here, which, thank God, it's not a bunch of data. It's very easy to read. There's red is saturated, which is over 150. Then we've got elevated in the yellow. That's 130 to 150. Then we've got the desired level, which would be 130 or below. And mine came in, the breath at 141.3 and the saliva at 145.9. So obviously when I got that, I'm pissed. I'm like, I am the healthiest guy. The term health nut, if you Google that, should just be my face. I mean, honestly, I've been obsessed with health for 22 years. Before that, I won't talk about because I was the antithesis of anything healthy in many ways. But man, I mean, I've done the 30-day niacin sauna detox flushes where you take copious amounts of niacin and you sweat like a freaking fire hydrant. I mean, I've done sweat lodges. I've done IV ozone, the oxygen chambers. I mean, when this came back, I'm going, this is impossible. How is mine elevated and past the healthy point? Because I think I'm so healthy and I've done everything.
Yes.
So what do my numbers tell me here?
Yeah. So just let me comfort you here.
Yeah.
With the, you probably saw the movie when Robert Williams is talking to this. I think it's The Beautiful Mind. Yeah. When he says, "Son, listen, that's not your fault.
Right.
That's not your fault. That's not your fault. Okay." It's coming from the environment. So it's really not your personal fault. It's practically a number of it's probably the time we live in. Right. There's no, because of climate change, and that's, we came from an ice age to a climate change that is warming, unless deuterium is fractionated from the ocean. There's more deuterium getting into the oceanic vapor, so our crops, our food, our drinking water have higher deuterium. Caveman was adapted to 10 ppm lower. If we were cave people, this would be probably 130. So practically everybody is dealing with the same problem as you, and we all breathe the same vapor. We all eat, I would assume, similar things, at least as far as food source go. But practically, this data shows where you should be. That's below 130. We believe that's the biologically desired range. That's what plants are doing for us. There's a saturated range, which is truly a deuterium overload in our opinion. And there is in between ranges where are, I would say, the most common values or most common events that may happen simply because of the environmental deuterium exposure.
Yeah. So what if for the past, I'm being hypothetical, obviously, so we're going to take science out of this. What if for the past 22 years, instead of me only eating organic, collecting my own pristine spring water, doing the saunas, doing the detox, the ice baths, all the stuff I've been doing, what do you think my numbers would look like if I spent the past 22 years eating at McDonald's every day, being on 3 or 4 pharmaceutical drugs, drinking tap water, living like the average American?
So I think it's two things. You see, more importantly, yes, you would have higher numbers. They would be higher. Pick a number. But the more important thing is even what you've been able to do is at least be able to maintain an ability to deplete deuterium. What we see with people like that, they can't deplete it. So it comes in their breath number and their number in their urine or saliva is the same. That's where it's scary. Right?
So I got 3 or 4 points here of a spread between the breath and the saliva. Does that tell you that I'm depleting some of my own?
You're depleting some on your own. We still have to get that better. And even what we call a healthy life, it's always interesting. You know, I'm one of those people too. Healthy, healthy, healthy. Unfortunately, you know, our understanding of what health is and a health style is probably kind of skewed. You know, I know that you know we all take the right supplements and the right minerals, the right vitamins, and I would say yes, you take great deuterium adding pills, great deuterium, and so those things that you think are great for you, they come with some really bad side effects, and that bad side effects is you're completely increasing your deuterium levels, so it's not helping you. It's not helping you at all, or it could even be hurting you. And so that's the interesting thing about what we've done and what we continue to do. So, and we will blame it on, as we said, well, I have to do these things because the food doesn't have the nutrition it used to have, doesn't have this in it or that in it. I don't know.
I'm definitely going to get into the supplements and the different foods and things like that that are heavy in deuterium. I just looked down and my dog just ripped a huge hole in the carpet.
Oh, I heard him going at it.
Yeah, I was like, what does that sound? Oh, that's just unraveling of the wool. Right, okay. This is where you can tell if you're a real meditator, you know. Does the heart rate increase when the $400 rug is destroyed as you're having a conversation? I did pretty well, actually. I am going to try to mitigate the project she's working on down there. You know what it is the moths got to it and they made a couple little holes, and then I think she was like, oh well, the moths did it, what's the problem? So here I am I'm at 141 breath, 145 saliva. If I just leave this as is, what exactly does this high deuterium level in my body do? My understanding of it from a very simplistic point of view is that when the deuterium's high in my body, it breaks the nanomotors in my mitochondria, which prohibit my mitochondria from creating ATP, which gives me energy. Do I have that right?
That's one of them. Mm-hmm.
That's only one thing that's wrong? There's more to it? That sounds bad already. So now that I have these levels, now that we know what deuterium is, like, what does it do that's bad? Give me the whole horror story here.
Well, you just talked about, first of all, energy. Energy is the one that's simplest to understand. You know, Nobel Prize given for it. We get that. And that's very, very important. As a matter of fact, that's our tagline, energy for a better you. But and that's big because that energy, you can imagine if your energy is 10% less, people go, oh, what? If you looked up in the sky right now and saw 10% less stars, you know, we'd have an emergency, right, going on. But that's really what goes on in your body. 10% over 20% less energy over 20 years means your immune system's not working, means your skin cells are dying, means all these things that needed to be funded can't be funded. So it's a big thing. It's a very, very big thing. Even 2% is a big thing, right? Now, the other things it does, which is, you can imagine, hydrogens are, I always say, and it's not scientifically perfect, but to talk about is if these hydrogens are also like the screws that keep things together, because they're the things that help maintain, that determine the three-dimensional structures of things, right? Because it's the charges on them and all these interactions they make with the other different elements that are in the molecules they're in. I said molecules. We have a running joke on that.
Yeah, I know. I remember that from our last conversation.
So by doing this, you can imagine. So now what it's going to do is going to change the three-dimensional structure of a protein, the three-dimensional structure of that DNA. So they're not going to work the same way they did before, just by bystander effects. Laszlo likes to talk about this effect that's called tunneling, and I'll let him cover that because it's amazing the stuff that he's really come up with and understand. Every day we come up with he comes up with a different understanding, and we try to apply it to what we do. But just think about this deuterium. When you have deuterium, the boiling rate is now going to be different than when you have regular hydrogen. So that's the same thing, and it essentially could have effects on the temperature in your body. Could have effects on a lot of different, the rate at which your enzymes react, right? So now it could slow your enzymes from reacting the way they're supposed to do. It could change the three-dimensional structure of a molecule. So now that lock and key thing doesn't work. It doesn't work as well. Is that what diabetes is? We think diabetes has a lot to do with that. Right? So it's not only, so it could change the way insulin is. We know for a fact the most important nutrient in us, which is cholesterol, that you get once it becomes deuterated, that it changes and it now can't be used to make the precursors for vitamin D and for estrogen and for testosterone and for progesterone and for bowel and for all these other things. This is important too.
Whoa! So you're saying when your cholesterol is deuterated, when it's full of deuterium high, then it is not usable for those foundational.
That's right.
Building blocks. Well, that's interesting.
Yeah, and they don't have to be fully deuterated. That's the point. That's why the set point, like temperature, if it's like 1 degree higher, it's like everybody's like, oh, where's the doctor? Where's the doctor? Because, and that's true of all human beings. Their average temperature is 36 point, again, in that range, 36.5 Celsius. So, and that's probably the same with deuterium. The normal should be 120 ppm. And the reason for this very delicate kind of barrier and normal kind of threshold, like normal ranges, is because hydrogen, the hydrogen or proton that we harvest from food, drive like nanomotors in your, that's how you produce energy. They are like hair dryer machines. They actually like electricity, but in this case it's a proton or hydrogen passing through a membrane in the mitochondria that spin these, practically rotate these nanomotors, and these nanomotors generate ATP at 9,000 rotations per minute. It's actually faster than your car engine.
Wow.
And at any given time, it's about 1,500 protons per second that are transferred through the membrane. So you can do the math. If there was one deuterium at natural abundance, 155 parts per million, which means that every 6,600 hydrogen would have one deuterium, at this velocity or this transfer rate, every 4 seconds, a nanomotor breaks down. Biological systems cannot deal with this high deuterium concentration. So mitochondria work without deuterium. By the time your metabolites, your water gets down to the mitochondria, it should not have any deuterium. So if you exceed your threshold when you consume food and you eat too much of it, by the time your food gets down to the mitochondria through glycolysis, cycle, there's a number of biochemical functions that break down food for you, and it's not just breaking down, it's actually getting rid of deuterium. These mechanisms are not sufficient to deplete them all. So your mitochondria are going to get a few of those, and a few of those are enough to break your mitochondria and cause mitochondrial damage that will damage your cells. So you don't, deuterium is more, as we do more and more analysis, as we do more and more testing, as we think and position this, it's more like an art, to finding out what deuterium you start out and how deuterium is actually being controlled by biological systems, if they are controlled, simply to generate energy for you. Because that's how you have your well-being. That's how you feel your state of body or biological mechanisms are able to actually work in harmony with your environment. If deuterium is too high, then your body has to adapt to a higher deuterium environment, and we don't think biologically it's that flexible of a system. So we think it's actually deuterium, if it's too high, our body is having hard times depleting
so interesting
those.
Because there's so much talk about mitochondria now and having a lifestyle and a diet and even supplementation to support your mitochondria. Dave Asprey from Bulletproof did a whole book called Headstrong.
Yeah, but again, they don't discuss the most important function of mitochondria, and that's the basic function of mitochondria is actually to produce water.
Oh, okay. Okay.
It's not to
I'm
produce
just thinking, like,
energy.
oh my God, there's like a lot.
No, no,
Okay.
no. The mitochondria has very little original biological role in generating energy. In evolution, it was actually the sun and the reptiles who actually didn't drink water. They were actually making their own water from food. That's why they could propagate in the desert, and they used the sunlight for energy. Now, as we move to the temperate climate, we use the mitochondria. We recycle this water. This is why we can produce more energy.
Wow.
But actually, the basic biochemical function of mitochondria, and I'd like to emphasize this as a biochemist and as a professor at UCLA, is to produce water. This is why you breathe in oxygen, and this is why you harvest food, hydrogens, and you breathe out carbon dioxide, because you don't need the carbons of food. You need the protons or hydrogens from food, which you attach to oxygen, and you make metabolic or matrix water. Now, what happens to this metabolic or matrix water? That decides if your mitochondria is producing energy, ATP, or you use this metabolic water as a chemical solvent and you use it for your body's hydration. That's what the animals in the desert do. But obviously they have sunlight, or so they don't have to produce ATP as much as like we here in the temperate climate. So
a polar bear then would be not using sunlight to produce energy. It would be making its own metabolic.
Yeah, that's why they have to
use the mitochondria more to produce energy.
Yeah, but that's why they have to eat those big fatty sea lions, because that's the only way they can survive close to the Arctic Pole, simply to the North Pole, simply because they have to generate ATP from their food, and they have to breathe oxygen in, meaning that they produce their own water in their cells, and they recycle that water. This is why they eat snow,
Right.
because they still have to eat, have water. Once you recycle your metabolic water to produce energy, then you have to drink some water or
so you're saying
some oil.
The physical body of an animal actually makes water almost out of thin air.
Has to make water.
Right.
I mean, that's
like the planet making something I've talked about before is primary water. That's the spring water that the planet actually makes. It comes out of somewhere down there outside of the hydrological cycle. It's just a fascinating thing. It's just
it's actually a circle of life. The photosynthesis role is to break water to produce hydrogen and oxygen. That's why the trees actually release oxygen. It's from water. And they use carbon dioxide and the hydrogen they harvested from water to produce organic material. That's what you eat, and that's what you burn. Again, you use the oxygen that the tree produced for you, and now you digest, you break down the food, you harvest the hydrogens to make water again, and you breathe out the carbon dioxide so the trees can start the whole process from the beginning.
So cool. I love the science of nature. It's just so
It's very simple. Truthfully, you can only make it more complicated.
I know. I almost wish we had like a chalkboard and you could just kind of draw out this cycle, because when you describe it like that, I go, oh, that actually makes sense. It's perfect. It's perfectly sensible.
Some of my talks I do. So at YouTube, there's many college lectures that I gave at different colleges and teaching at UCLA. So it's actually out there.
Yeah, and it is so cool, because this is not a small statement when we're saying that. Because, again, we were all trained in medical school and graduate school, and we didn't know this. We studied ATP, and we can, in our dreams, can go through the cycle and say this many is made from here, this many is made from the Cori cycle. And then Laszlo comes up. I mean, it's his discovery. Make sure you understand that. Comes up with the understanding that, no, the function of mitochondria is really to make this metabolic water. And then it all makes sense. Because, as he always likes to say, there's no reason to have, how many is it, 10?
Yeah, again, it's not my discovery that mitochondria makes water. Actually, discoveries back in the 1930s when Nobel Prize were given out for the Krebs cycle, Krebs-Engerdi cycle, when the nanomotor, these rotating protein particles. Actually, the 2016 Nobel Prize in Chemistry was given out for these working nanomotors and working proteins in our system. And it's very basic biochemical information. That's why you can't really question its validity, because do we breathe in oxygen? Yes. Do we eat food? Yes. Do we make water? Yes. That's what oxygen is for, and that's what the hydrogen from food is. Is this water deuterium depleted? Indeed it is, if you eat deuterium depleted food, which is natural grass-fed food. If this food is grain-fed or GM or whatever they do in the pharmaceutical or in the industrial process to our food source, it's usually deuterium enrichment, meaning that they feed the cow the fat source we burn into metabolic water with something else the cow would need, unless they lock him up in a barn and they just feed them with grains or protein supplement. Whatever they feed them is not our food, and it's not the cow's food. So actually what the cow produces as meat source is not it's really not healthy for us. So practically when it comes to understanding deuterium, is we have to go back to these very basic, very fundamental biochemical routines and information and build our knowledge from there.
That's so interesting about the body being able to produce its own water. Would you tell us the story about, I want to go into the desert animals more. You told me before about the camel and how it's able to use all of that fat in its hump to produce this metabolic water that it then hydrates with. How does that process work?
Dr. Q is the camel expert.
Okay, do the camel thing.
We
the camel.
We love camel. There's a great book called The Alchemist, and if you read The Alchemist, there's a part in it to where there's an Arab merchant, and there's a young kid that's going out to the middle of the desert to find all the gold. And he tells the kid, he goes, whatever you do, when you go, I'll just get a horse and ride a horse. And the kid is so confused because all the rich people only ride camels. He says, no. You want to ride a horse because as the horse goes out, you can tell how old a horse is. And as the horse goes out, to ride it back, and you'll ride it back, right? And you'll see it getting older and older and older. And then you get a new horse because you don't want the horse to die in the desert. A camel, on the other hand, he said, you can't tell the difference between age and a camel. And the boy didn't know this because he was a poor kid. You can't tell between a 7-year-old camel, a 30-year-old camel, 40-year-old camel. And what will happen is a camel will walk, keep walking, and die in the middle of the desert, and then you'll die. And he says, why? Because, the camel's hump is totally fat. It's not water. And they take all that fat and they change it into, as he said, metabolic water. So camels don't get sick. Camels don't get cancer. Camels have energy to just keep going, and they die when they're supposed to die, when they just wear out. And
so is that water that the camel's making in their hump with that fat, then you call it metabolic water, that's water that's depleted in deuterium? So are they in fact a deuterium depleting machine?
They may be ugly, but they're incredibly deuterium depleted. We want it as our mascot, and Dr. Cooper wouldn't let us do it.
It reminds people of Camel cigarettes.
That's the excuse she used.
When you say give me a Camel, I mean I'm like that brings me back to 1986, man. I used to smoke a pack a day.
But they got it right. I don't know. But these camels, it's so neat because they don't drink water. They eat cactuses. They eat cacti with all the spike, and we watch the videos of they literally eat them, and they make their water from probably one of the most deuterium depleted plants on this planet.
Ooh, that reminds me. I want to ask you guys about tons of foods and stuff, but one thing that I eat a lot of is raw aloe vera. Do you think that, like a cacti, would be low in deuterium? The gel. I eat the gel.
All green or organic, all material that is produced in plants are deuterium depleted. Okay. Even the sugar.
Okay, good.
If you eat sugar from beans or green plants, glucose, at specific carbon positions, which is the 3rd and the 5th carbon and 6th carbon, those are actually heavily deuterium depleted carbon positions.
All right, I'm gonna get into some more of the food stuff as we go along here, but I didn't have my pen with me. I don't want to forget. Every morning I put a huge fillet of aloe in my little morning tonic, So I was like, oh man, I hope that's not bad because it's so good for the gut. Okay, I want to talk about some specific conditions then, starting with diabetes. When we met before, Q was telling me this miraculous story about a kid who had, I believe, type 1 diabetes, went through the depletion protocol, and within 10 days or something tested negative for the markers. What's up with the diabetes and how it relates to deuterium levels?
Yeah, so again, we need to clarify a few basic things. Actually, one is very important. Diabetes only means you have plenty of urine. It has two types. One is the mellitus, which is sweet tasting urine. In the mid-ages, when these diseases were described, actually physicians, doctors, they tasted urine. That's why they named these diseases. Well, that's what's dedicated to your craft. That's why it's called plenty of urine, which is sweet. That's when you have
to sit with me for 10 minutes. Drink my tea.
Well, historically, to understand, that's where it takes us back in time. Now, there's diabetes insipidus, when you don't have this vasopressin or antidiuretic hormone. You have plenty of urine, but it doesn't taste sweet. So that's why we call it a different diabetes. But diabetes doesn't mean that you have problems with your sugar. That means you just have plenty of urine. Now, if you have glucose in your urine, then you have high glucose in your plasma, about 200 milligram% above, your urine is going to be, it's going to have glucose. Now, truthfully, when it comes to diabetes mellitus as a disease, it really depends on how much glucose you eat. Because human diet should not contain much glucose, simply because we only have access to fruits seasonally and we eat meat and fat. So we are practically predators in that our ancestor. I'm talking about our evolutionary background. So and we did have cases of diabetes. One is published in the medical literature, type 1 diabetes, lack of insulin. If we feed these kids with no glucose in the diet, but more fat and meat, it's more fat though, that's more desirable, you can actually cure their diabetes. So they don't need insulin. Probably the human body does not need insulin only in extreme situations when there is fruits available, when there is more sugar in the nature, in the environment, then we would need some insulin digesting some fruits that we ate. Yet you can truly cure diabetes, type 1 diabetes, without insulin, simply giving the patients a natural ketogenic diet. And one of them is already published in the literature, one of these cases. It's very important because dealing with population diseases and looking at obesity, diabetes as one of the biggest medical burdens of our days. And if you learn that actually the normal laboratory values that you consider diagnostic and the diet that you feed to patients can actually normalize, again, quote unquote, we are looking at laboratory values of a carbohydrate society practically, because ever since this carbohydrate mania started, that's where public health started going down. And it's simply because we shouldn't eat carbohydrates, we shouldn't eat glucose, we shouldn't eat sugar, we should eat fat, we should eat meat, and seasonally, just so the trees can propagate themselves. We can eat fruits just for the very short time they are available in nature. Now, obviously now if you go to Ross, you can get cherries shipped in from Chile. So obviously these rules don't apply to our diets anymore, of how discriminative we should be against fruits and sugars, and how much meat and fat we should eat to keep our health. And simply going back to your original question, there are species who still live 300 years. Just look at the Galapagos turtles, the elephants, the crow, some birds. I mean, we have actually a human lifespan is very short compared to historic species that are still in their environment. So, truthfully, depleting deuterium through food and not being exposed to sugar and high deuterium source food practically can or cure these diseases would not manifest. This is why I'm telling that once your deuterium level is below this 120 ratio, then you may not have diabetes whatsoever. It clinically just does not manifest. And actually, insulin as a hormone that takes care of glucose, if you consume a lot of glucose, it has a little C-peptide which actually speeds up these nanomotors, so it just burns everything in your body. So even your hormones that you don't inject with the insulin, you inject insulin without the C-peptide, which actually takes care of these nanomotors. Even the therapeutic approaches do not consider the physiological role of this complete biological substrate oxidation or combustion that can actually get rid of every excess metabolites in your, including glucose. So the treatment of diabetes, first of all, below certain ppm, it doesn't exist, this disease.
Wow,
and if
that's
you eat,
profound.
and if you
That's
eat,
heavy.
and if you eat actually functional food, meaning that you only eat food that is available in your local area, and you eat what you are designed to eat, which is meat and fat, mostly, including cholesterol. And the problem with, for example, cholesterol that we were talking just a minute ago is this tunneling effect, which Q was mentioning. Protons or hydrogens in the body, they move together. It's like a football game. You know, whatever you need hydrogens for, that's, you know, when the quarterback throws the ball, all the teams are running that way. That's we call the tunneling effect. It's like pushing them through a tunnel. Practically, they can't turn around. It's just a physical entity that they have to follow based on chemical bonds and chemical electromagnetic fields they generate for themselves. If you insert one deuterium in this kind of hydrogen football game, practically, as they move together in body, if you introduce one deuterium, it's enough to actually disable 1,000 hydrogens around them.
Damn.
That means, like, when you protect, you know, when you actually put road blockages to this, you know, very important biological function of hydrogen to move, and to move proteins, and to generate, by moving proteins, energy for our body, a deuterium can break down and stop hydrogens from, or protons from moving by the thousands. So that's why MRI can indirectly reveal how much deuterium blocking these radio frequencies in the magnetic field, but actually the image is based on proton movements, because deuterium can compromise that very significantly. So all these, I would say, very revealing medical devices that they are based on proton movement or proton tunneling, they are very dramatically compromised by deuterium, and that's what you see in images, and that's what you see in laboratory results.
When did you come up with the part of the testing protocol that involves the MRI, and what's the advantage of doing that, and what body parts do you do, or do you do the whole body?
So in our partner Esther, she studied images of eggs in MRI. It's a T1 sequence, and it's 1.5 Tesla. We don't need high magnetic field or high energies. We want to have the deuterium's isotope effect to show. So if you look at an egg yolk and the egg white in an MRI, it gives you an image simply because they have different proton contents, and we measure those with isotope ratio mass spectrometers, and those numbers match. Meaning that if you measure your deuterium content in your egg yolk and egg white, and you actually compare that with the luminances of the image, it's a deuterium, indirectly it's a deuterium measuring device. Or it gives you the same numbers practically. So we figured that we should look at cancer images to see if there's more deuterium in there, or look at the biochemical hallmark of cancer cells, which are defective mitochondria, so unable to deplete deuterium. And sure enough, when you look at these images and you look at enough of them, you can see that practically these biochemical defects will lead to different concentrations of deuterium in various body fluids and tissues. And you can actually, by pixel and pixel, you can actually do a mathematical algorithm or a mathematical approach, and in that case you can actually differentiate among tissues how much deuterium, or in the same tissue you can actually tell if there's a deuterium accumulating kind of tumor, and you can actually see how bad it is as far as accumulating
That's cool.
deuterium.
So say someone has pancreatic cancer, then you could MRI their pancreas and see how much the deuterium level in that organ is playing into the pathology?
Well, yes, indeed, for the therapeutic approach or for the clinical positioning approach. But yet, if you actually don't see the tumor yet, but your computer can already find a cluster of pixels that are darker, but visible, not distinguishable, your computer can already alert you that there are pixels that are not normally distributed in the same tissue, and you need to magnify or need to be careful because there is an unproportional deuterium distribution within the tissue.
It's pretty neat because we can't say definitively now, but essentially what we're saying is that we can take things and put them on top of each other and say, okay, that's interesting. That thing you called a metastasis is lit up. This is lit up. This is lit up. This is lit up. Oh, by the way, here's some things you missed.
Whoa,
that's the cool thing. Like, here's some things that you missed. And then as we go with the Deuterium depletion protocols, we start to see those things be less lit up, right? And so the question comes to be, when we talk about cancer and treating cancer in particular, but other diseases too, it's not, we can get away from the idea of the cancer itself needing to be out of your body. Who cares? What you want is a cancer that's not growing, that doesn't have enough. If it's blocking something, that's different. But you can live with that. I mean, it's an interesting. You just don't want to be able to grow and metastasize. So if you can turn it off, you turn it off, and that's what we kind of look at, trying to turn it off, and then let the immune system take care of it. It's going to take care of it. If it's not, it's not. But it's not going anywhere. It's not going to hurt you.
How does high deuterium compromise your immune system, or does it?
Yeah, I mean, there's first of all, high deuterium levels are associated with inflammation. That is inflammation, and inflammation is one of the guiding factors to the non-antigen associated side of immunology, right? What the macrophages are looking for. But then, on the other hand, too, it also has an effect on even our killer cells and these other components there, the ability to actually to be able to let off growth factors and different kind of factors that are going to bring a T cell to a particular place to kill something. So with these high deuterium levels, and again, even going back to the simple, basic fact, not enough friggin' energy for the immune system, because it works harder than everything in your body. It works, always is working, and it will burn it out. So if the deuterium levels are high, then there's not enough for this immune system to keep working, and it just stops, because it is a high energy thing, very high.
And then how about when the converse is true and you have an autoimmune issue where the immune system's going nuts on your own body?
Well, my thoughts is we talked about that before. So we do also believe that the autoimmunity is caused by deuterium. And again, when we say these kind of things, we're not. The reason it sounds like Windex is because this is at the basic molecular cellular level.
Right.
So everything's based on it's the foundation of biology. So this is a basic tenet of it. So we're not trying to bring in something that's new.
Right.
This is science.
Right.
That's all. If we're wrong, then we're all in trouble. But remember, putting that hydrogen now into a protein is going to change the three-dimensional structure, just like it made cholesterol not as useful. So once you change a three-dimensional structure, it's no longer self. And so now you can get it, and that's in your adrenal gland or in your elbow or wherever it is, whatever that three-dimensional structure has been changed. Now your immune response says this is foreign, right? And it starts to attack it and raise an immune response to it. Now, if it sees if this is the one place that deuterium is starting to show some effect, it's not only one molecule, but it's going to be thousands and millions of molecules just like it, because that is the problem. That's why it's there. And so now that's what I believe a lot of the autoimmune diseases are, and that's to self. Now, there's also autoimmunity where it's dysregulation, to where, again, these T cells and this precision, this precise ability to recognize antigens is not as precise as it used to be, because even those cells are tired, right? And again, we start to see a lot of things like gluten and all these other things that start to look a lot like these three-dimensional structures that have deuterium in them. And gluten is a high deuterium. It's loaded with deuterium. That's why it's bad for us. Not because it's gluten. It's because it's loaded like deuterium and looks like a friggin' thing that's loaded with deuterium inside our body. It's not gluten.
That's so interesting, because that's never in the conversation, because I think the awareness of this is still rather obscure.
One interesting observation among physicians and gynecologists is that once somebody becomes pregnant, their autoimmune disease subside and cancer too. So probably as the fetus collects deuterium for their growth, depletes the mother's host. Just to go back to your original example, that's why I try to use this as an example. So autoimmunity is probably very much dependent, as Dr. Q said, it's very much dependent on your deuterium load in your body and what tissues accumulate deuterium. Another interesting aspect of this is that practically your gut flora, your gut, your body, you are actually part of a biological fauna or ecosystem, if you will, practically, and you have 1.5 kilograms of bacteria in your gut and in your body, simply because you have to deplete deuterium for your body. So these bacteria, they actually rotate these little protein nanomotors the opposite direction, so they retain deuterium. So that's why they actually grow so rapidly. And stool is nothing else, practically just bacteria that accumulated deuterium and organic material. That is, some of the food is turned into this bacterial mass simply because of the deuterium content. So we believe that our biological systems are designed, and these symbiotic relationships with bacteria and fungus and protozoa, whatever you host in your body, is simply because they deplete deuterium for you, and you keep feeding them. And you keep feeding them, so they actually deplete your deuterium in your food, yet you keep feeding them so they can propagate as well with deuterium. And probably the insects like flies, they fly on poop, doggy poop, simply is because of its high deuterium content. Because they live on, they have short lifespans, they have to propagate very efficiently, and that's all controlled by deuterium.
Oh, that's crazy. It's funny. Those of you listening, you might have heard Cookie. I just had to take her toy away. She's getting real squeaky. She's never had this much energy. I swear to God. I'm like, usually she'll play for a minute. She sleeps, man. You guys are giving her good energy. Maybe because you guys are all.
I'm depleted. Yeah, we do. Yeah, we already.
Get a little.
But something that you made me think of. Yeah, right.
No, I'm actually not joking, because our breath actually now equilibrates with all living things in this room, and actually she's enjoying now the low deuterium bread from humans because we are deuterium, and now she's active.
Wow, that's so. I mean, honestly, I'm like, this is weird. She's very kind of, I would say, lethargic.
Hey,
in a
Cookie,
negative sense, but she
Cookie,
is
just
lazy.
go at it, buddy. You're low in
But,
deuterium. You're allowed to do anything.
Back to the dog excrement. One thing that's so strange to me is when I take the dog for a walk and she leaves her soil behind. Instantaneously, flies appear out of nowhere. You know, and I'm like, there was no flies here. There's no flies in the air passing by. You know, it's like they materialize out of thin air suddenly, and they're on that turd
Indo and Scato, the smell of the dropping is practically modified conjugated cholesterol molecules that are loaded with deuterium.
Wow,
that's why they have a different smell.
That's what I love about, because when we put
or the products of those.
The story is just amazing. It's like it's from A to Z. We can explain how these things fit in, and if we can't explain it right now, we'll know tomorrow, because it's just fact.
It's so fascinating. And before I forget, I want to give a shout out to Dr. Jack Cruz and to my buddy Matt Maruka, who's a protege of Cruz, because Cruz is the first guy, if he ever hears this or sees this, he's going to be like, oh, really? So you're into deuterium now? But I would ask him about supplements and stuff, and he'd be like, nope. It's loaded with deuterium. It's like, what is it? What are you talking about? What is this deuterium? And Matty, who's younger, and I know you've met Matt. He's one of those guys that can take pretty complex scientific ideas and present them in a way that makes sense. And I interviewed him, and he's like, "Oh, it's all about the deuterium, man." So before I forget, I'll give them a shout out. I wanted to get to a couple other, issues that people have. So diabetes. We touched on cancer a little bit. How does this relate to Alzheimer's and other, cognitive issues that people experience?
You want to go?
You go first.
Right.
Yeah.
I love sitting here with you guys. It's like a badminton game. It's like, who's going to take it? Pong! Goes to the other side of the net.
Well, again, Alzheimer's is diabetes type 3.
Oh.
So that's really what it is. So there's several things going on. One, the inability to use for insulin receptors and to use glucose in the brain appropriately. But the really incredible things about it is that, again, high levels of deuterium, even in the brain, do end up doing this. So you have this inability to so by doing this, it can't eat as well. It can't do a lot of these things. And again, remember, 60%, I think 6% of the glucose is used by our brain. So if you if you get your glucose from, again, grass-fed animals, and it will all turn into glucose, the amount that you need will be there for this brain. But now what we've done instead is you go with this high-carb, synthetic carb, high deuterium diet. And so the glucose that you're feeding it over the ability to deplete deuterium is now just a glucose bomb to the brain. Hence, we have a lot more cognitive problems, including Alzheimer's, epilepsy, TBIs, all these, the reason TBIs are going up, these traumatic brain injuries, may not indeed because we're living in a more dangerous society, is our brains are simply much more susceptible to them because the deuterium load is much, much higher now. So that's
what have you guys seen in terms of doing the depletion protocol? And those of you listening, obviously we're going to talk about the solution and what you do about this in terms of diet, lifestyle, and depletion protocol. Have you guys seen any miraculous things happen with dementia or Alzheimer's from?
Oh yeah, definitely. First of all, we all know about the things with like Mary Newport and using MCT oil, coconut oil, using ketogenic diets. So all these things that they talk about. I hate to bust everybody's bubble, but it's simply they're deuterium depleted foods. That's all they are. And I'm one of those, I'm one of those people that were big in the ketogenic diet, and a lot of stuff out there came out of my lab and the research that we did. However, as Laszlo was so kind enough when we met 3 years ago to explain to me, it ain't special. It's not. I love the fat summits and the skinny on fat. No, it's just the skinny on deuterium, because that's really is what is important. So we've seen incredible.
So that's because I have heard a lot about people having dementia issue reversals and Alzheimer's reversals from doing a ketogenic diet and healthy fats and all that. So you're proposing that this has a lot to do with why that is.
It has the only reason.
Okay.
It's not a lot to do with it. It's
why it works.
It's why it works.
Oh, God,
As a
so
matter
cool.
of fact, we can replace that because especially with the brain, and once they can't use the sugars and all this stuff, they have to use other pathways. Using deuterium depleted water puts that ketogenic diet and things on steroids. So now it works much better because I can tell you, if anybody's ever worked with a senior population, getting to eat a keto diet is close to, like, just give them rocks and snakes. They're not doing it. It doesn't work. So instead, but if you give them the deuterium depleted water, it does work. It really changes those things. So it's crazy, but it does. So it makes. When we'll talk about that later, but the deuterium, we always say the deuterium depleted water it works, but as Laszlo like it works. The major way it just makes bad diets better and shitty diets less shitty. So and it helps.
You said it nice. Yeah, that's how it works. Yeah.
And there's two more issues that I want to.
Can I just step in here just for 1 second?
Yeah.
Every cell in our body can make glucose from glycerol, net glucose. Liver cells can release it. So when you come, and some very specialized cells like brain cells and sperm cells, they have to get glucose from glia cells or some supporting cells, and then brain cells need glucose because they are producing so many neurotransmitters. They need a net source of carbons for biosynthesis. And only the substrates, 25% of the substrates that the brain cells use have to be glucose. The rest of them can be ketone bodies. And they need at least 25% glucose. Simply they can support their net biosynthesis process, which we cannot really do from ketogenic diets or ketone bodies. And there are biochemical reasons for this. I'm not going to go into details. The other important element here is what Dr. Q was saying, that actually Alzheimer's disease is an accumulation of glucose in the form of proteins. It's part of this histological change in the brain area that is affected by Alzheimer's, because those nanomotors are not efficiently oxidizing completely glucose or some other substrates that are accumulating. So practically you can, by low deuterium, you're improving the mitochondrial functions. You're able to prevent a lot of what we call molecular crowding disease, where actually you are not able to use your exhaust system to get rid of and generate energy in the meantime of your fuel and its components. So practically we have to look at biological systems as a biological combustion systems. Your exhaust pipe has to be just as well functioning as your intake pipes. And when there's when there's actually a difference between how much you can burn and how much you eat or consume, then you're going to end up with a surplus that you can't really handle throughout your life, and you develop certain, various diseases. Now, it's probably the same problem everywhere, but the tissues, as they are affected, they're going to produce symptoms that are specific to the function of that particular tissue. So fatty liver, fatty brain, protein-loaded liver, protein-loaded brain, they have different clinical symptoms, but they can be traced back to the same metabolic abnormality.
And this, I'm assuming, also would lead to obesity also.
That's correct.
Because think about it, again, like you said, you eat something, but if you're not going to use it all up, that's why it starts loading and getting this metabolic crowding, which I think it's funny. I'm going to, just a quick tangent, which is what all the supplements out there, people going crazy about all these supplements, like NAD. It's great. No, it's removing metabolic crowding. It's not great.
And the truth is,
I meant to put NAD on my notes.
Yeah.
So that's what.
And your true exhaust pipe is not your, it's not your digestive system, it's actually your lungs. That's where you breathe out carbon dioxide, and this is where you take in oxygen. So your true intake and exhaust system is your lungs, because that's where you take in oxygen, and that's where you breathe out carbon dioxide and water. The rest is pretty much just to supply this combustion system through food, which is for hydrogens. You don't need the carbons, you don't need the nitrogen, just you need some of it, but it's more like a replenishing what you have lost during the day. But what you burn, what you produce as your energy, is like your car. You have to fill it up certain times. You have to have your carburetor running appropriate. You need oxygen for that. But all the oil changes, all the tire changes, they, are a different story. You practically need to fuel it right, and you have to use the optimum gasoline. You have to eat good food, and you have to have oxygen to actually operate those machines. And we are very much similar or the same, yet we don't really watch what we put in our system. That's the basic problem.
What about this NAD thing, dude? And there's two more issues I want to cover, but
you get into that. Let's see how you get out of it.
I've heard a couple of podcasts about it, and there's one product I've been taking called True Niagen, which is not NAD, but the precursor. It's some kind of vitamin B1 or something. I gotta say, I have a lot of energy, on this stuff.
Well, again, think about it. So if you're able to take firewood that didn't get burned in a first fire and have this place out here and burn it another way, great. You can be warm for a while, but you're still going to freeze to death in the future because you can't keep doing that. And like Laszlo,
Robin from Peter to pay Paul. Kind of
well,
thing?
Laszlo liked to say, I like this because he explained to me this. What was it? You only need enough water donkeys. You don't need more. You need more water donkeys. In other words, this is how much you've got to move, right? And so you can put in a couple more water donkeys to move some things, but adding another 40 water donkeys can't help because you don't have enough here to be moved. So once it gets rid of the metabolic crowding, then they're no longer necessary. But here's a way to do it: eat less. You can go the other way and stop metabolic crowding by not giving it so much resources, which is why ketogenic diets for cancer patients, they always talk about it being a calorie-restricted diet. It's calorie-restricted so you don't get this metabolic crowding, this other stuff left over. That's why. That's why it has to be that way. But that's also, if you have it more deuterium depleted, then your motors are running, you have more motors are running, so you have less metabolic crowding, and there's no longer the true need to have a calorie-restricted diet in this case, which should be good for all of us. So that's what we really concentrate on.
Well, food in nature is always restricted. Even though, like, you see these lions in the Serengeti, they're like, okay, there's a zebra horse there, but I'm not that hungry, because they have to run. They have to catch him. They have to kill him. It's only
expense.
Yeah, there's always in biology, in nature, there's always a reason to eat because you're hungry, or to drink because you're thirsty. In human societies, it's not the same way. They practically always tell you, like, you haven't eaten enough of this, you haven't had enough of that. Actually, I think 90% of current populations, they have a disease called diabetes insipidus, meaning that they don't have anti-diuretic hormone because they drink so much water that they develop clinical symptoms, plenty of urination, because they drink so much water.
Dude, a friend of mine the other day, he's a new friend, so he hasn't heard my whole spiel on shit, especially about water, and he was saying something about, he goes, I make sure I'm never dehydrated. I drink a gallon of water a day, every day. And I was like, I said, man, I really don't think you need that much water, but what kind of water do you drink? And he's like, tap water. I heard, they sent me a thing in the mail saying the water was safe. I'm like, oh my God, I'm like going out of my skin. I'm like, I wouldn't drink a shot glass of tap water.
Here's
a gallon a day.
Okay. Now here's the question to this person. Here's the question to this person. Does she know, or he knows, does he know that actually his body produces water?
I didn't know that until I met you guys. So he definitely doesn't.
Now, how much water your body produces, if we would just sit here, do practically nothing, just talking, not exercise, not running, nothing like physical work, exercise or any of that nature. If you just sit here in a room, closed eyes, and you just maybe just keep thinking of your like dreams, whatever, you produce about 1.5 liters water a day. Because as you breathe in oxygen, you actually, per minute, you use about 350 milliliters of oxygen gas. And from there, you can calculate how much water you have to produce for that oxygen to be chemically bound and recycled in your system. And that's, even if you don't do anything, you are probably in the range of 1.5 liters, which is 1/4 or 1/3 of a gallon. Your body is producing, and you haven't done anything. Now, if you run the marathon, that's going to be 20 liters. That's going to be at least 5-6 gallons. I think it's in that range. Because you produce 60 kilogram ATP, you turn it over, meaning that you break it down and you resynthesize it. That means you actually produce a lot of water. You can't drink as much water as you can actually produce in your body if you eat the right diet. And if you're aware of this biochemical information, then you would probably stop drinking that much of water, simply because if you hydrate yourself from outside, your body stops hydrating itself from inside, so it cuts down this antidiuretic hormone production. Your ATP synthase is not rotating, because these hormones have very critical biological roles of regulating this water production. If you shut them down, you're practically left without metabolic water. And obviously that's going to affect your health on the long run. Your body is still trying to produce, well, it has to produce water, but all the excess that you drink is practically high deuterium, like what your body has to deal with, water source. So your body would actually get rid of it through saliva, through sweating, through urination, and through vapor that you breathe out, exhale. So learn a little biochemistry, do some reading, and find out how much water your body is producing, and drink accordingly.
How much water do you drink per day?
I don't drink water.
You don't drink it at all?
No. No.
You gotta be shitting me.
No, I have a coffee in the morning, which is about like a coffee mug.
Yeah.
That's what, 2.5 deciliters. And the rest is just practically olive oil. And I eat fat. I eat bacon.
Wow, fascinating.
Yeah.
Fascinating.
And I don't get thirsty. But I have high ADH, antidiuretic hormone levels, which is not common nowadays.
Okay.
I retain my metabolic water. Very preciously just, keep it. I don't drink excess water unless I'm doing physical work and I'm thirsty, and in 20 minutes I'm still thirsty.
Right.
That's my, because hunger and thirst are put there simply that when you have to eat, how much you have to eat, or when you have to drink and how much you have to drink. Because eating and drinking, anything you find or anything you buy or anything you hear on the radio or television, it may not be good for you, even though they say it is good for you, because they are trying to sell you something. Bottled water, fruits from, that they shipped in from overseas that you don't need, you're not in the season. Maybe it's not even known in your local neighborhood where you're exposed to certain proton pressure or photon pressure. That's Dr. Cruz's topic. These systems come hand in hand. These systems are actually very interconnected, and you have to know what your life and what your light is doing for you, and how it can be incorporated into general health as far as your deuterium load.
How much water do you drink, Q?
The Diet Coke count? No.
Dude.
I thought they'd make you jump off the wall.
Oh, man, yeah.
No,
drinking LA tap water is one thing. Drinking Diet Coke that's made from tap
He can make me drink a Diet Coke once a week.
Yeah, I can do it. It's actually funny. We actually did measure deuterium levels in Diet Coke and tap water. The Diet Coke's lower.
Wow.
So that was some of the shocking things.
Did you test LA tap water?
Yes, we've tested LA tap water.
What number did it come in at?
It's at 149, 150.
Damn, that's
fairly
high.
high.
Right?
Yeah.
Very high. But you can eat actually bad stuff, which is even higher than that.
Okay, we're gonna get into that. I want to cover. Okay, but before we do Q, I didn't quite get the NAD thing. I got a little lost.
Here's the thing.
So let me just let people know. There's two things you can do. You can go get an IV of NAD put in your body, or you can take a precursor that helps your body to produce more, which is what I've been taking, this True Niagen, which I love. Now I got to see if it's synthetic or if it's a plant derived B1 or whatever it is. But the NAD injections, to me, intuitively, I was like, I'm not into it. I don't even need to know anything about it. I just feel my body's like, nope, don't do it. And then I did a little research. I heard some podcasts, and the guy who, of course, he's the guy that came up with the True Niagen, a scientist, and it's a precursor, and he was like, it doesn't do you any good to put straight NAD in your body, and B, you still need the precursor anyway, so it's sort of pointless. So what's the deal with that?
So I agree with you. So the IVs don't, again, it's overkill. I don't know what that would be for. It's interesting for the precursor. But precursors would be necessary because you had less of something. If you don't have less of something, you don't need a precursor. Or if your precursors that you have are contaminated, a la, cholesterol, and you can't make the product you're looking for.
Got it. Okay.
I will go with that. That makes sense. The problem is the biological systems are very complicated. And anytime you put, and I can't think of one single instance that this is not true, anytime you put something in, you can get to a point to which you down-regulate the ability to make what it's supposed to make. So that's the only problem that I have with that. I guess it will come to a point to where you're hurting yourself.
Right.
Now, if you're not making enough NAD to support the production of ATP, I get it. I can't sit here and draw how that would happen. Right? I can't.
So, any of you know what NAD does?
I know. Here you go.
No.
He does this to me all the time. But he asked me this question last week, so you can.
Yeah. So, when you actually harvest protons from food or your hydrogen from food in your Krebs energy cycle, actually your hydrogen is given to NAD first. This NAD carries this hydrogen to your mitochondrial inner membrane and gives this proton, this hydrogen, to a complex called electron transport chain. They rip off the electrons from this hydrogen and they push the proton without the electron out in the extra matrix space, the intermembrane space, and this proton will come back in to meet oxygen to produce water. NAD is an important water donkey, as like he pointed out.
So I'm still not even that clear what a water donkey is.
Water donkey is that carries like a workhorse. There are two buckets.
I just rolled with it and I was like, I think I get it.
No, there's like two water buckets, so they get filled up, then they are emptied. Then the donkey walks back.
Got it. Okay.
Filled up, emptied.
The water.
So
why you put a donkey in the pond?
No, donkeys don't like water. No, they can go for long without water simply because they eat the cacti. They eat anything. They can even eat a Coke can. I mean, donkeys are fantastic.
Metaphor understood.
Yeah, but the water donkey in your mitochondria is this NAD. Because it gets the proton from the Krebs energy cycle, takes it to the electron transport chain, it goes back empty. It picks up another proton, takes it to the electron chain, goes back empty. So practically this is why you can't really mix up these ratios, because if you don't have too much food but not enough water donkey or NAD, then this proton transfer is not sufficient. Now, NAD has another role, which is very important, which is an extracellular kind of compartment because your body, your cells are trying to get rid of deuterium so badly that extracellularly there are already mechanisms to pick up protons that can be harvested from various metabolites, for example, from red blood cells, which use glycolysis to break down glucose and carry oxygen, but they produce lactic acid, so they don't have mitochondria. So practically, NAD is a proton carrying distributing molecule. It's big enough that it cannot really leave the cell or the mitochondria, or actually if it's phosphorylated, it's even more bound to that particular cellular compartment. So practically they transfer this hydrogen or this proton, but once you load them with deuterium, they can't do this job simply because deuterium binds to them 10 times stronger than hydrogen. So then you have to replace them.
Interesting. So whether or not I was adding exogenous, synthetic NAD through an IV, or I'm taking a B vitamin substrate that is the precursor to my body producing its own NAD. Again, we're going back to the root issue here, is that if there's too much deuterium within that whole system, then those things can't even operate anyway. So why don't you just deal with the deuterium itself?
But again, you have to remember that anything you eat, it already has a lot of NAD in it, because it uses this NAD for every creature, every living organism has this biochemical system to transfer protons, and that's with NAD most of the time. Well, there are kind of modified NAD molecules, but their basic structure is always the same. You can attach a phosphate to them, so they are more like cell compartment bound, but practically what they do is they just carry protons. But once you hit them with deuterium, they have to be replaced. Okay. It's like pouring the water donkey's bucket full of mercury, the donkey will collapse.
Right.
And you have to get a new donkey.
Way to use that metaphor, man. Bring it on.
What?
Well, now I can. Now I at least am properly visually, picturing the donkey out of the water, carrying the water. So we've got that part. So the last two things, and then I want to get into the depletion and the levels in different foods, supplements, water, all of that kind of stuff. And I talked to you guys briefly about this before, because my mom has Lyme disease for a long time, or at least we think it's what it is. It's just such a weird, ambiguous kind of condition. But what about these, Lyme infection or the co-infections and things like that? How would deuterium levels play into, the level of severity of an issue like that?
So Lyme disease, quite personally, is just a definition of a metabolic dysfunction. And that metabolic dysfunction, the reason Lyme disease is so misunderstood is because it can show a lot of different phenotypes or look a lot differently. Because again, all it is at the beginning, you're affecting the amount of energy that you have, ATP. You start to get fatigue. You start to have an environment that can grow bacteria and viruses, and all these things can happen. That's what Lyme disease is. So by lowering the deuterium levels, returning not only the ability to make energy, but also returning the ability to make biological molecules that are effective and efficient, that are the right shape, the right function, then you start to see a lot of those things associated with that we call Lyme disease. You start to see a lot of those phenotype, those things that they report, those symptoms disappear. So it is we have several Lyme disease patients, but it's a long haul, because again, it is so many different things happening to that person. And we find it very interesting. We have to be when we have Lyme disease patients, we have to be very, very careful to document what they're going through, because as each thing disappears, they forget about it. So I can't get up, oh God, I'm so tired. But I went walking today for a mile and a half. I've never done it. 2 weeks later, well, God, I'm still tired. After I came back from my 2-mile walk, right, or this back hurts. It's ridiculous. And then it's like, oh God,
Usually the way I put it, if medicine hasn't figured out what's causing it, Guillain-Barré, chronic fatigue, Lyme disease, it's caused by deuterium.
Wow.
They just call it autoimmune. If the wind is from the north, they call it, exhaustion disease. Even it's a different wind. It's just practically whatever supplements they want to sell, on, these
Right.
determined medical causes. You can just name any cause practically that will fit because they don't know how it is. High energy production would interfere with your energy balance and your well-being simply, and that's what you master practically is your energy production through low deuterium, and then these diseases actually change their phenotype and course. And these patients, since there is no symptoms, there's no it's just practically your well-being is not as like you are accustomed to or what you remember like you were young or when you were energetic. As soon as your energy level comes back, forget about it, how it was before. I did have chronic fatigue, be honest with you. Back when I was at Ohio State, I guess, coming from Europe to the industrial kind of food paradise, the United States, which I'm very thankful because this country gave me a lot of opportunities. I'm Hungarian by birth and by education, yet truthfully, I could tell there is a difference in food quality and food composition simply because I got very, very sick. I couldn't get out, of my bed for a few days. I was very tired constantly, and it has a certain. And then as I adopted, it was a little bit easier, but I had to deplete deuterium to be like back to normal as I was.
Well, that's hopeful. That's good. I can't wait to help my mom get on this protocol. The last issue I wanted to cover, and then we'll get into the next bit. So the audience is. I torture them with this stuff. I either torture them or they love it. They keep listening, but I want to know every little thing about every little thing. Because once you guys are gone out of here, what'll happen is they go, damn it, I forgot to ask about autism and vaccines. Which brings me to my next thing, and that's the last one I'm going to cover. A dear friend of mine has a kid, and I think the kid's 5 or 6, and was healthy, and then after a particular round of vaccines, the kid just went off the rails and has all of these sort of, autism spectrum things, and is just having a really, really hard time. So I was curious, I know the answer now probably after going through a number of these things. Okay, deuterium is an issue with the autistic tendencies. Do you think it has anything to do with the actual shots being really high in deuterium? Is there any correlation there, or is that a stretch?
No, there's not enough deuterium itself in that shot to do it.
Okay.
No, not deuterium itself.
Okay.
But what we see in the patients that we have is that their deuterium levels are high and their ability to deplete deuterium is high. I mean, even though they're young kids, and it's just a very, very interesting thing. So we lower the deuterium, and yes, it does help. It definitely helps. Now, also, it's the same thing. Now, we can talk about what components of lowering that deuterium means, and we can go over the presentation of autistic children or autistic adults, and the presentation is such that you would, with a pencil, write down all the things that I say, and you would say they don't deplete deuterium, and it's just a fact. So you have to fix those things to approach it, to get at the, they actually have deep problems with their deuterium depletion mechanisms.
Got it. Okay, cool.
Now, in my take is practically infectious diseases have their own deuterium depleting potential from the population. And I'll tell you a good example. Flu is always like the beginning of winter. That's when we are most loaded with deuterium because the summer seasonal deuterium release through warm weather is high. The fruits, we have eaten enough fruits of seasonal fruits of the fall, so our deuterium is high enough to have an epidemics of a virus infection, which uses the cells which actually change the rotation of these nanomotors and retain deuterium. And immunizing against these diseases is to actually decreasing the ability of our populations or certain populations to actually let individuals or populations go through this deuterium cycle, practically to accumulate and then deplete, accumulate and deplete. Obviously, immunology is a huge part of this, and it's not necessarily the deuterium content of what they inject. Obviously, there are some material in there which I don't get flu shots or any shots, or I don't recommend anybody, but or immunizations which are really not dangerous, large epidemics like infectious diseases like the whooping cough. There are like the paralysis, the childhood, just there are diseases that are very dangerous from the population point of view. Our populations have dealt with them in the past. Nowadays, there are passive or active immunizations available, which, again, may have very disadvantages, like when it comes to population health. I think it's related to deuterium biochemistry. Simply, we could understand these trends or disease epidemics better if we understood deuterium biochemistry better. But this is what our centers does. We actually measure, we compare, we interpret, we recommend deuterium depletion, and we see these clinical courses. And we hoping, again, we are building a kind of a database where we can actually use this information to make more thorough and more general recommendations. Right now, what we can say is practically there are cases where we can improve these conditions by deuterium depletion simply.
Well, that's a perfect segue then. We're almost 2 hours in here, and I'm finally getting to the solution. But man, I need to nail the problem, okay? I need to make sure that I understand what the problem is.
Of course.
Okay, so I want to get into the deuterium depleted diet, the deuterium depleted water. Before I do, I just want to ask: is there any way to deplete or detect the deuterium levels in your pets?
Oh yeah.
Yeah.
Yeah, the same way we get. So we, again, I had the Kita Pet Sanctuary in Austin, Texas. So we had 100 dogs that we treated with cancer.
Really?
Oh, you didn't know that?
No,
yeah,
dude.
yeah. That's how I started all this. Shout out to Quest Nutrition who financed all that.
Really?
Yeah. So, but we started. The idea was to see if a ketogenic diet, which at the time I didn't know was the deuterium depleted diet, that if we could use this on dogs, because dogs couldn't drive to McDonald's, if we could use this in a controlled environment to show that it worked on cancer. So we had dogs from sanctuaries, dogs from private owners, but mostly from rescue centers that had naturally occurring cancers. Some were so huge it was 20% of their body, but we treat them with diet, with deuterium depleted water. We use hyperbaric oxygen therapy. We use IV vitamin C. Everything I could think of to try to treat the dog, because the whole idea was if we could show that, then we could move that on to what I wanted to do, and that was to create meals, deuterium depleted meals, to treat people that had cancer and do clinical trials to prove ketogenic diets work for glioblastomas and other cancers. We did that. We were very, very, very successful in dogs, to the point that we had no dogs or very few dogs that died of cancer. They could have died from the damage of the cancer or from even killing the cancer. We could kill it so quickly that they went through tumor necrosis or tumor. They would get essentially die from the junk that was in the tumor, right? And would die from tumor lysis syndrome. Excuse me. And to the point that we didn't see any metastases, and saw some metastases go down. And that was what was really neat about that. I did this to begin with what I call the pet cancer trial. I started this 2 years before I came out here to do that. And we had such success with vets saying, oh, this dog has a sarcoma, this dog has an osteosarcoma, this dog has this, that once we treated the dogs with this ketogenic diets and everything and all these other different kind of things that now we know deplete deuterium, that we would take it back to the vet, and the vet would say, oh, then I was wrong. So what we did in the Keto Pet Sanctuary, we had our own PET-CT scanner, a $5 million machine that was that was in a trailer that we could take any place. And we had that, so we measured every single dog before the dog went on treatment, 90 days into the dog was on treatment, 180 days, and then 6 months, and watched the status of the tumor all the way through it.
Oh, that is
It was the most.
Yes. So in Europe, Vetera 25,
Yes.
deuterium depleted water is a registered anti-cancer drug for veterinarians.
wow.
So actually, deuterium depleted water of the 25 ppm range is a pharmaceutical product in Europe, and it's a registered pharmaceutical product in Europe to treat dogs with cancer.
So if you have a dog that's already well, like Cookie here, she has one thing that's a little funky, is some allergies. So she's very itchy.
So-
you know, and I'm giving her homeopathic drops, herbs.
Stop.
Trying all this stuff.
Stop.
Give him bacon,
Yeah.
you know,
It's-
with his food. Pour a little olive oil on it.
Okay. I mean,
And-
she's keto.
No,
Like,
no,
I don't give her any
but
grains or any
we
funny
just have to.
business.
We
I give
just
her
have to-
raw
so,
meat.
So we just have to tune it up a bit. And
Okay.
that's really just it. It's
Okay.
just like
Meat or fat?
Okay, I'm on that.
okay.
I'm
so,
on that.
So that's really comes down to is all these things are simply from just that. And the other thing is we'll talk about it too. Some of the problems we have the way that we've domesticated animals and created. So it's their breathing has been hurt, and you can find out the dogs that have an inability to breathe or to breathe well. And we'll talk about this later when you go through the deuterium. That means they can't bind as much to get rid of deuterium. That's why those breeds have more cancer than other breeds.
Wow.
So these are the kind of things that we're making.
That's
it's
crazy.
like we sit up and go, yeah, here. It's like it's great. Like let me make the test out here. Here's
Well,
the
what's
answer.
interesting about, when you're talking about the trials that you're doing in Texas there with the dogs and feeding them a ketogenic diet, to me, the first thing that comes to mind is like, duh, that's what a dog's supposed to eat. Like, why would you ever feed a dog, or a human for that matter, anything other than good quality organ meats and fats and things
No,
like
no.
that?
Again, not the meat. It's the fat.
The fat, okay.
So you have to. The dogs would eat interiors. They don't eat filet mignon or sirloin steak of like a rabbit. They leave it for the vouchers. They eat the interiors. They eat the organs.
Yeah.
Yeah. If you look at just like how lions hunt, they actually the first thing they open the body. They don't start eating like, let's eat this piece
The
of meat.
shoulders.
No, the
That's
shoulders. No.
interesting.
No. The first thing they do, they open the body. The male lion can break the femur bone of the zebra horse. So they eat the interiors, including the balls, the bowels, the lungs, the hearts. They leave the filet mignon and the sirloin steak to the wash. The hyenas.
So
They don't.
Yeah.
They and that's why they are on top of the food chain, because they get to the fat first, then the interiors. No other species, no other predators or scavengers who actually eat the less fatty or less deuterium depleted part of the animal, they are not competing with these heavy, strong, fast predators simply because they have too much deuterium in their system.
Interesting. So with the dogs and the pets, if in Europe the 25 parts per million is this therapeutic, medicinal sort of aggressive depletion water, I mean, could I give my dog the 85 ppm as her drinking water for a period of time? Or
We'll talk about that.
Well, why don't you do an experiment?
okay,
Give him tap water
uh-huh.
or give him 25 ppm water.
Oh, and see.
They're
which one
always gonna. They by smell they can tell.
Ooh, that's cool.
Actually, animals can smell.
Will it work with the 85 ppm that you guys?
You can
gave me?
deplete only a few ppms. The dogs will already pick it out.
Oh, that's cool. I'm gonna do an A/B test. I'll
Yeah.
take her out for a long, hot ass walk. Come back, pour two exactly the same bowls
Please.
with each
Yeah,
water.
please
and
do
see.
it.
That would be a great video. Okay, so let's get deeper into, and thanks for the information on the pets too, because a lot of people have been asking me about their pet health and as it relates to so many of the things that I talk about on the show.
As a matter of fact, and I wanted to finish up.
Yeah.
From being so successful there, then we were able to then do clinical studies in people. So we did a lot of different small studies on glioblastoma patients in Arizona. The last one, they did one with Cedars-Sinai here. Not clinical trials through the FDA, not those, but for people that wanted it, and it wasn't double blind. These are glioblastoma. You didn't have to be double blind. You're going to be dead in 14 months.
Wow.
So if you're not dead and you don't go through the horrendous things that entails with this type of cancer, we found the answer, and it's very effective. But it's only as effective as the tools you bring to the table. In other words, if you're keto, again, it's really deuterium depletion. Mm-hmm. And as Laszlo said, it's all about the fat. And so as we understood more and more about this, now we can understand why a 4-to-1 ratio was important. But more importantly, once you use the water with it, because keto isn't, so we need, once a person or a person with advanced cancer, is their cancer cells can't process fats. Can't use the TCA cycle. It's not the way it works. It's going to use glucose. So that's when we really start to have to use deuterium depleted water, because that's the reason it's very, very necessary, and why a combination of these two things work better in the clinical setting rather than one or the other.
Let's talk about the water. So you guys brought me a couple of cases of this water because I want to get this damn deuterium low in my body. I'm very good at compliance too. I'm not one of those people like, oh, I forgot today. Like, I'll be obsessed with whatever protocol I'm doing. So you guys are gonna love that. But it's 85 ppm, and then you talk about in Europe they have this very low 25 ppm parts per million. So how do you determine which type of water you give to a prospective patient or customer that wants to undergo this protocol?
What's really nice about what we do versus other people that are starting to sell this water, I don't know why you're selling it, since you don't know what to do with it. There goes my commercial. Anyway, so this has come after 20 years of research and actually being able to use this in over 7,000 cancer patients. And we have, I don't know how many diabetics and how many. It's just from experience and really getting to understand this, and Laszlo coming to the table and understanding, more importantly, the biochemistry behind this thing. Again, that's what we bring to the table, and that is a total understanding from A to Z about how this works. It's not simply about the water, but about how the water and the diet and the breathing and everything goes together, and how you actually make it safe. Because while it is water, and it is not water that exists on this planet naturally, we have to create it, right? And so it's more, as we said, it's a drug for dogs with cancer in Europe. And quite frankly, in the United States, we're hoping that someday, as we do our clinical trials, and it's going to be a drug, the law will be a drug for people in the United States and any place else, because this is as effective, if not more effective, than a lot of standard of care. And if nothing else, it makes all standard of care work better. And there's plenty of papers to support that. And that's chemo and radiation, a lot of the medications that suddenly don't, well, Laszlo likes to tell the story, because there's a lot of now clinical trials that are failed, and magically now they're going to use deuterium depleted diets to make it work. Like, oh, well, why don't you just not use the medicine?
Yeah. They have to sell somehow. They're failing.
It's kind of cool in a way, though, with this technology, because if you guys had come up with some magic supplement or another drug, right? Especially in the world of alternative healing and things like that, you get a lot of heat and pressure from the regulatory agencies, right? I mean, the FDA is going to be on your ass if you come out with anything that's like, oh, we figured out how to cure cancer. Oh, really? In other words, like if you're competing with big pharma, you could get freaking assassinated.
Well, our problem is
know?
we actually taking something out of the water. We are not supplementing or giving you something
That's what I'm
access
saying.
that
So it's
you
kinda
know.
cool
We
you
are
guys
taking something out of the water. So the regulatory aspect of this is, I would say, pretty simple in the sense that we are not adding anything to or in your system or body. We are actually taking something out of your food and water. So that's a different regulatory perspective. The other important element is that when you actually do a clinical trial, which is randomized and blinded clinical trial, you have to be able to interpret the data from the translational clinical point of view, how efficient it is. Do you have, let's say, integrative approaches to integrate this into existing treatments? We don't tell and never tell and would never tell patients to discontinue anything that they are currently doing because of the recommendation of their licensed physician. I'm not licensed to practice medicine in California. I'm just teaching this. Now, if the patient has questions, if the patient wants to know why this is better for them, or even want to relate this information to their doctors, we can direct them to the appropriate material. We can direct them to the appropriate lectures and biochemical information that they need to incorporate in their process of taking care of medical problems. Simply so we would like to have this knowledge and information available for patients and doctors and whoever is interested in learning about these. We would like to have this position, as Dr. Q said, in certain aspects and certain treatment methods and modalities. We are very happy to collaborate at any level with anyone who is interested in this type of approach. We provide data. It's not a guessing game. The report that you saw is practically tells you what your deuterium level it is, what is your efficacy of generating energy compared to a industry, or better to say, to a plant-based standard, capsaicin, which is 109 ppm, compared to that where you are, as your food is saturated with deuterium, and how that would affect your ATP synthase, nanomotors. And the third panel will show you what's the difference between your breath and your saliva. So your environmental food source is how much higher than it's your metabolic food, your water source, or the surrogate of it. And we would like to see that at least 7 to 10 ppm apart. As you can tell from your report, you're only 3 to 5 ppm apart. So it's your breath is not that lower from your environment or from your saliva. So your body could do better if you would deplete deuterium using either dietary or, drinking deuterium depleted water.
So with the water then, say someone has my, standard deviation or excess levels there. Editor, please hit that one for me. When I or anyone would start on the depletion period, how long would I follow this keto diet, and how long would I do the water, and why would I be doing 85 parts per million instead of 25 or 45?
So there's two things. So we started you at 85, but we could have actually started you at a higher amount. Think of it as like diving, right? And as you're diving, the lower amounts, the quicker you dive down. That's really what it is. So we like to start a lot of people at 85, so they feel this energy boost, or they get to where they need to get there faster. But 105, 125 is fine. It just takes longer to get there. And if your diet is bad, now yours is not. If your diet or something is bad, we know 125 may not be great, because you got to make up for something that's I started at 85 because we wanted to. Right?
I see.
Didn't have to.
I see.
Okay, because you're a wellness patient. So that's but at the same time, more importantly, and Laszlo is, could speak to it really in detail, we are totally against, again, knowledge is everything, right? And wisdom is being able to know how to use that knowledge. We have the wisdom of how to use this stuff, not the knowledge. They can read our papers. Everybody can be an expert. They think at this. The problem is, if, for instance, if you were to use 25 ppm, and that's what you're going to use, you could set up a person's body to be able to be a place that could actually grow out of disease in time, right? Because you're young, but if you had diabetes or you were older or you had weight gain, I know I'm not going to start you off lower because that's not the problem that we need to address, and we don't want to get into the point to where in 10 years you have a cancer, right? And that you go off of this, yeah, and there's no place to go down, right? You're already using 25, so if there's a cancer at 25, then what in the heck are you going to do now?
Right.
You can't get any lower than that, right? That's the biggest problem.
Right.
So yes, so we use different ones from our experience and from our incredible clinical load that we've had to make the right protocol, and that protocol includes water, but it's not the only thing that's in the protocol.
Got it. Okay. So with said protocol, say I test these levels now and I exclusively drink the 85 parts per million water for, and breath work and other things that we'll talk about, whatever that might entail. How long would that typically be until one retests again to see like, oh shit, we knocked it down by 5 points?
You're going to be ready to retest in 3 to 5 weeks.
Oh, that's
especially
fast.
you. Yeah, it's going to come down fast.
Wow.
We may go longer, and there's 2 days. We know it's going to be down there quickly, but we also want you in the zone for an amount of time so you feel it. It's both ways. I mean, we hate to say it. We know biologically when it could be down in 7 days, but a patient can't appreciate that, right? They have to wait 21 days when they're, oh God, I feel all this energy. Then they're happy. I can see better. I can walk better. Then they buy in, because half of this is just because there's already single supplement and this and that, and everybody thinks it's equal. It's not. Yeah. So we do have to deliver bang for the buck.
So it would be probably unwise then for someone to just go, oh, I want to get this depleted water and go online and just buy it and just self-administer and drink it all the time randomly then.
Well, again,
so your body is constantly designed to get rid of deuterium. It's just practically how much deuterium you feed to your body. You have to allow time of your body to actually adjust to a new set point, to adjust to a new deuterium environment. And that can last for a long time based on like where you started out at. I mean, and you can trace these changes simply your physical activity, your mood, your focus and ability to concentrate, your exercise routine. You might be able to withstand like physical injuries. There's a lot. Your nail is going to grow slow. I used to cut my nail every week. Now I just cut them once a month because they grow so slow. So once you learn how to live with low deuterium, and I usually recommend diet more than water because I don't drink water. To me, deuterium depleted water doesn't do much because that's how I make my coffee, but the rest is pretty much lots of olive oil on my salad, and I eat, if I don't eat bacon, then I would eat a steak at night, which is a T-bone steak. I don't eat sirloin or high protein steak. I eat the fatty stuff because simply that's what you need to produce metabolic water efficiently, low deuterium metabolic water, and you allow your body, if you will, for a few years to adapt to this low deuterium environment. And it's going to show up in many different functions of your body that you can feel, not in the first week, not in the second week, but maybe a few months or even a few years down the road. And you can always expect something new to feel or experience if your deuterium is low enough. I'm not going to give you examples because, that might not be for...
So if one wanted to become aware of this on an ongoing basis in more of a long-term self-treatment or monitoring protocol, then they would get their levels tested, they would, adopt the certain dietary recommendations they're about to cover, they do the depleted water for a period, live in that sort of lifestyle, then retest, see how the levels are doing, perhaps do the water again, and once you get down to a certain threshold, you just kind of go back to living life as normal, being mindful of a low deuterium diet or a keto diet.
Yeah,
Is that the idea?
you go from a health style to a lifestyle.
Okay.
That's really it. So lifestyle, once you understand this, these are the things I can do with my lifestyle to keep my deuterium levels down.
Okay.
To keep my ability to deplete. That's a lifestyle. What we do in the first is that health style therapy thing to get you into that zone to be able to do that.
Okay.
That's the thing that's going to usually take, depending on how, if it's prevention, but maybe take, we always say 4 months. 4 months to make measurable changes that you can feel and see, right? Almost to everybody. Or everybody, no matter what it is, you're going to see that by that time. Now, if it's a serious disease, or not a serious, but more metabolic damage that's been done, that could be a year. That could be 2 years. I mean, we often have cancer patients who have been very successful, knock on wood, that it keeps up like that. And we're always amazed because it is, to this day, I'm still amazed that somebody who is a stage 3 or stage 4 cancer patient who does well, and the question they always ask us, into it is like, well, when can I stop? And to me, it's like, I don't even understand what that question is. I don't, but we constantly get that. It's like, okay.
You mean because why would you stop doing?
Yeah, it's like I don't.
You
You're alive now. You wouldn't be alive.
So if someone's listening to this and they're like, "Whoa, this has resonated with me. I'm on board." Would they go to ddcenters.com, order the saliva and the breath test kit? You ship that to them. They take that. You get their results, like I got mine in 3 weeks or so, and then you guys would say, hey, this is the water you need, these are the dietary recommendations you should follow. And
we actually, one of two, the answer is yes, but usually what we can always tell everybody, yes, you're high. Right? So what we always say is you can start when you do the test. We want the test done first, but that day the water's there, you make your changes, we measure in 4 or 5 weeks to see where you are, that you're in that zone. And let's face it, if you're compliant and you're not in the zone, you're seriously sick, right? There's something wrong. And so that's when we really have to go into it, and that's a big advantage too. Then we can go pull things apart and work with your physicians to try to figure out what's going on metabolically, right? What's really going on with you. Right. But yeah, I mean, that's what we say. You start from the day it is, because even like you say, you're the healthiest man on the planet. But the planet's not healthy.
I'd be doing great on any other planet.
That's right. Well, we can talk about that later.
Not really. Yeah. Time machine to go back.
Well, it's not the Morse because the team is like 800 ppm. So it's not, currently NASA is looking at this situation because shrimp doesn't grow there. But, it's as efficient. So deuterium, actually pharmaceutical companies deuterate pharmaceutical drugs so their breakdown is slower. Deuterium heavy water is a MRI contrast material.
Oh yeah, people don't want to get that contrast stuff, right? If they get
there's so many applications already of deuterium. They are just not aware of it. So we are filling in the biochemical information that they need to understand where deuterium comes into health and diagnostics and to treat diseases.
I gotta ask, with the water, this depleted water, it is super expensive. It's like a few $100 for a case or something, right? Mm-hmm. Why is the damn water that expensive? Is it really like the machinery necessary to create this water super expensive? What's the process?
Yes, I mean the process of doing it is an expensive process, and it's more expensive as you make it lower in deuterium. That's the catch, right? I mean,
precisely.
Yes.
Pharmaceutical grade. Because currently the water that are available at our clinic, those are actually registered pharmaceuticals in Europe. And the tower which is a deuterium fractionated. You can imagine a tower which is twice as tall as this building, has a electric and condense, like cooling plates to condense water. Constantly you have to monitor the intake and the deuterium fractionation ratio. They constantly have to control for the equipment to operate in a very precise. It's not a range of like, it's in the range of like 50 and 55. No, the water that is available through not just like our clinic, but practically it is what it is. It's not in a range. It's not a guessing game. It's actually a pharmaceutical in Europe. And the tower is a pharmaceutical tower. And it has its own certifications.
Where
it's in Budapest. It's in Hungary.
Manufacturing facilities are there worldwide that are making real deuterium depleted water?
There's just one GMP facility in the world. That's ours.
Wow.
That's
yeah.
If you go on YouTube, there's some knuckleheads that are trying to make, no offense if you're one of those knuckleheads, but
so deuterium depletion now
in their kitchen by using ice cube trays and shit. Can you make this on your own at all?
Deuterium depletion now is kind of becoming a buzzword. They know it has a biochemical, medical, translational application in medicine, so they think it's. Now, truthfully, deuterium depletion is always and everywhere happening. It's a physical process. It's like, usually I tell my students, deuterium is always like when it comes to water source, it's practically the heavier kind of, your physical systems always get rid of it, but fractionate it. Physicists like to use the word fractionation because the new fraction of water has less deuterium than the old fraction of water through evaporation. And people try to make deuterium depleted water at home at few ppms or few parts per million. Let's say they boil the water, they condense the water, they distill the water, and from 155 ppm or 150 ppm they get from the top water, they go down to 148 ppm or 146 ppm. That's not a whole lot. And they already are paying the electricity bill for the heater and the refrigerator. So deuterium depletion is not an easy process. It's like if I would tell you lose a few kilos, it's not an easy process. You have set points as far as what your deuterium level is in your body. Your body is constantly trying to get rid of it. Nature is trying to get rid of it constantly. This is why we think it's very significant that the cavemen lived in a lower deuterium environment, because then their fractionation was easier, simply. So when it comes to these medical deuterium depleting ratios, like 85 ppm, by the time you do this in your kitchen and you actually precisely measure it and it's surely in that range, you had to build a chemistry lab. You had to buy an $80,000 instrument just to measure precisely deuterium content.
So effectively, you can go out and get a job.
You already
just buy the water from someone like you guys.
The cheapest of all sources with the pharmaceutical range of deuterium depletion is the water that is available at our clinic. Everything else that is giving you a range or giving you somewhat depleted, those are truly not the type of medicine that we are talking about here. I don't want to criticize. Listen, is deuterium depleted? Yes, it is. Compared to what? Compared to oceanic water. Is it deuterium depleted to a good ketogenic diet source? Let's say you're oxidizing olive oil and its components, phytochemicals in your mitochondria. Is the water deuterium depleted compared? No, it's not. Actually, it's a lot higher still. Whatever you consider deuterium depleted is always compared to the oceanic water source, but of your metabolic water source, it's really not depleted. So you have to go into our range below 105 before you can actually see some impact and some effect in your deuterium depleting ability.
But there will be, because of the progress we're making and a lot of the people like you being helpful to express to talk about, there will be other companies that will start importing and possibly building things here. I have no problem with that. The problem is they don't know what they're doing with it, and that's the problem that scares me.
So it's not that there aren't other people that could create industry where they're making legitimate depleted water, but it's more like understanding the protocol and how to use the tool. So someone can mimic the tool, but not necessarily give you a blueprint of how to build the house with it.
Again, you have to measure and establish your clinical scenario before you would recommend anything.
Okay.
Yeah, you can drink deuterium depleted water. That's okay, and you might use it for recreation. There's many different applications, but when it comes to therapeutic or preventive measures, you need the advice of somebody who knows exactly how biochemistry aligns with what you want to accomplish.
Okay. And then in terms of water, before we move on from that, so I found out from my friend, shout out to Jason Bozell. He's another spring water fanatic, and he's big into Jack Cruise's stuff too, and so we geek out on all the the light issues and of course water as it relates to that. And he drinks the same spring water. My buddy Mukunde, who's been on my show, has a company called Live Spring Water, and they go up and collect the water from the spring. He's got access to an organ. It's high altitude. The water comes out cold, low TDS. It's tested for every single contaminant known to man. It's clean as a whistle. Comes out impeccable lab results. So I've believed in this water. But when I found out about deuterium, I was like, oh, God, please don't let my spring water be high in deuterium. Jason texted me the other day, and he's like, yo, Dr. Q, and those guys tested our spring water, the live spring water from livespringwater.com, and it came in at a 139. Parts per million. I think that's pretty good, right?
So
for your general
like
drinking
I said, yeah,
water?
for general drinking water, go for it. Again,
it's obviously not.
Make your own. Yes, it is depleted. It's 139.
Okay.
It's not in the therapeutic.
Yeah, you can tell.
Yeah,
it's depleted by whatever 15 ppm compared to oceanic water. You can tell exactly how depleted it is.
It's depleted by the earth because that water originally came from the ocean.
Yeah.
Because it was in a mountain.
Yeah.
In snowpack mountain.
Yeah.
And that's deuterium depleted up here. The higher, it's up here. So now
because of this
melted up,
fractionation.
It's melted
like
and came
constant.
down here, and now it's 139. That is cool. Yeah. That is better than drinking most water.
Yeah.
But we always say, drink it, but eat right.
But what your body produces, on the other hand, 105 ppm.
Okay. So that brings
So compare your water to oceanic water and compare your water to metabolic water. You're going to see what the problem is.
Right.
Okay? So you're still drinking something that is way higher than what your body is trying to accomplish as far as its water source.
Okay.
Your water source is not the water that you drink. That's a misconception. Your water source is the water that your body produces.
The metabolic
Or
water.
the metabolic water. And that's
what the mitochondria is making.
That's the most inner compartment of your body is your mitochondrial matrix.
Trippy.
Yeah. And our job is really to return.
And you can only access that water compartment by food.
Okay.
Your drinking water will never go and penetrate and actually go through your bowel, your epithelial cells of your bowels. Then it has a basal layer, then it gets into organs, then it gets into cells, and it gets into mitochondria and has to pass through membranes there. I mean, you are talking about these 10 membranes by the time your water would get. So go down to the mitochondrial matrix. It's actually your water source that your waters you from inside. It's your sparkling system. There's rain coming from the sky, and there's your water sparkling system, and that's what your mitochondria do. Right. And that water source is different.
Got it.
So
from what you drink.
So in terms of the other levels, like if LA tap water is 150 something, that's not good. That's a lot of deuterium. Does doing distilling water or reverse osmosis water, is that still going to be high?
Listen, they all fractionate to some extent. Okay. It's measurable, measure it, compare it with your metabolic and your environment. I mean, listen, again, I like to, and we all like to work with data practically, and that's what
Yeah.
you need to generate to be able to formulate your own opinion about like what is good for you, what is really not desirable.
Sure.
But again, these are very good questions. I mean, these questions would allow us to point out both the benefits and the problems with this sphere. Yes, indeed, you can generate deuterium depleted water. Is it enough to reach your biological, what your biology is trying to accomplish? So that's the main question.
So that stream water, the spring water you have is lower than anything somebody is going to take their tap water and try to deplete it. It's not going to be as low as that.
Right.
Right?
Okay.
Just
good.
to let you know.
Yeah, yeah.
And so if you, in the reason.
So shit, I could get Makunda. You could sell your water as like, nature's deuterium depleted water essentially, but still it's not under the critical.
Yeah, it's good wellness water.
People ask a lot about. They ask me a lot about water because I'm so obsessed with this mysterious substance, and I know what they're going to ask now after this episode is these type of questions. Well, I drink this type and that type, but I like what you said. It's like, yeah, cool, whatever. Let's talk about the water that your body's making, that metabolic water. That
compare everything to that one.
That is lower.
Yeah,
so
then you find those answers.
So that brings us into diet. Okay, so we've been talking about, I think people have understood by this point at 2 hours and 34 minutes that we're going to be talking about a ketogenic diet. The first question that comes to mind, I think a lot of listeners will be aware of what we mean by a ketogenic diet, one that's free of glucose largely and carbohydrates and things like that. The thing that's always confusing to me is what does someone do if they're plant-based or vegan and they want to be keto? How could someone who doesn't eat animal fats, which I personally do, bacon, you say bacon, my mouth, I start drooling on the table with my high deuterium saliva. But a lot of my listeners they're not into it. So how could someone eat a paleo or a vegan keto diet in accordance with making it a deuterium depleted diet?
So we call it a natural. Again, and I've had it's as a natural paleo keto diet is what we talk about now. Now I've had vegans who we call which I coined the term Keegan diet. So
I like that.
so a ketogenic vegan, right?
Yeah.
So what we're able to do is to then add plant oils and those type of things to it. Now also to really key in on the food they're eating, and while they are vegan, we also want to make sure, and most of them do, that it's non-GMO, right? But then we go to the next step. We've had people who have cancer who will not eat meat. So then what we can do is source it from the best places that have the lowest deuterium levels, right? So you can get as low as possible plant-based diet, add proper oils, plant oils that are with it, that are as low as possible in deuterium, and get to the same, and with deuterium depleted water, get an effective therapeutic regimen.
Cool.
And when I say about therapeutic, what we do is not truly treat the disease, we treat the underlying cause of the metabolism. You fix the metabolism, you give them more energy, and then we always picture diseases really as a marker for bad metabolism and not the other way around.
And that's where the term metabolic disease comes from?
Yes.
Okay. Would that mean that you don't have enough metabolic energy and hence?
It means it's from, the best way to think is from the mitochondria.
Okay.
And now we know and it's not a DNA. It has nothing to do with your DNA.
Okay.
That's
you were saying that before we met. Yeah, just yesterday I was talking to someone about cancer and deuterium and stuff, and they went, "Well, I mean, if I'm predisposed, my uncle has it," and they're really indoctrinated into this thing that if it runs in your family, that you're going to get it. In some cases, there may be a very few cases or a lower percentage that have genetic cancers. That's true. Just like some that are viral cancers. That's true. But the great majority of cancers have metabolic issues, which is from as a mitochondrial issue. And that is everything we've been talking about this. And you can have a predisposition, but that predisposition really is you guys all ate the same thing. You lived in the same area. That's the predisposition. Right.
It's not. It's move.
Right.
Right. Move to Colorado.
Right.
It's like
Okay, so when it comes to the foods that are, on the good list and on the bad list in terms of the levels of deuterium and contributing to this protocol, so we could just safely say all processed foods would be out because they're going to be in high in deuterium, right?
Again, the simple rule here is that you are able to deplete deuterium if you only eat natural source food.
Okay.
Nothing that is processed.
Okay.
And once you start processing food and you start growing food and your yield is just so important, then you start adding deuterium to the food source simply because that's what makes him grow. You start using river water to water your crops, which are higher in deuterium than fractionated rainwater. You actually start using certain pesticides that actually just kick out enzymes that deplete deuterium in a normal environment. So that's what actually produces more food is these GMO protocols. You just by observation, they actually just do these food processes simply to generate more food and sell it for cheaper. And that's the I would say the richest source of deuterium. It's practically processed food, which is going to affect society. I'm not talking about just individuals. Through the individuals and the mass effect, it's going to be population disease exposure, just like what we see now. And regarding cancer, diabetes, obesity, neurodegenerative, Alzheimer, autism, these are all related. These are diseases of the last 20 to 30 years. But that's when food industry started producing who knows what. I mean, I don't eat, I just pretty much just eat what I told you. I just bacon and steaks and maybe a little bit of greens. But I don't really know what's out there.
So would it be safe to say that any food that has additives, colorings, flavorings, anything artificial?
You can just use Crisco oil, which is industrial hydrogenated oil. That hydrogen source, if it's from gas or if it's through water electrolysis, that may have deuterium 250 ppm.
Wow. So some foods are, way high in it, like
more
processed foods like
that.
Yeah. Okay.
Synthetic acid.
Okay. We measured using isotope ratio mass spectrometry certain fiber products which are actually worse than oceanic water.
Mm-hmm.
What about give me just a rundown of some foods that are interestingly high or low. I noticed on your site you had done an MRI. You mentioned an MRI of an egg where the yolk, which is the only part I eat.
Yolk is about 120.
And the
119. The white is at 140.
And then the coconut was interesting. That the coconut, the fat part is good.
Is the lowest. Yeah. The water is about 155 ppm.
Because that's where it gets rid of it.
That's what. Yeah. Okay. That's why no animals would actually drink coconut. Well, even the crab that breaks the coconut, they just actually eat the pulp from it.
Wow, interesting. And then what about fruits? You guys were talking about fruits before as being no bueno on the deuterium
again,
levels.
Fruit ketogenic. Why is it not good on a ketogenic diet? We thought it was because it's high in sugar. Yeah, that's true, but it's because the sugars in that fruit, in this particular case, and they're high because again the fruit is not from the green part of the plant. It's the part that I can't steal your thunder on that one.
Yeah, so fruit is actually a sugar load, and fruit the function of fruit in nature is practically to propagate the trees. So let's say there's fallen fruits from the trees, and the big carnivore, the animals would eat them, the herbivores, and they walk like 2 miles and they, excuse my language, they shit everywhere because they have a diarrhea from the food. From the fruit. Right. And they spread the seeds with a good fertilizer, with a lot of deuterium that the bacteria harvested from it. So fruit is really not a nutritional element in our life. Fruit is practically to propagate the trees that will actually deplete deuterium for us through photosynthesis. So it's a very well-designed biological system to actually keep deuterium as low as possible. There are different systemic hierarchies in this biosphere. Simply to deal with deuterium, either use it for growth or control it for longevity. But practically, all species adapt to a certain deuterium environment, and that's what define their role in the food chain. But practically, as it comes to food, fruits are actually the worst.
Wow.
And that's why you should only the highest in deuterium. That's why nature don't leave them available for very long. I mean, bacteria go at it immediately.
Yeah.
And it's interesting because we as mammalians, or we as humans, we can actually identify 4 different tastes. One is sour, then sweet, sour, and there are
umami and what, I forgot what the other one is.
bitter. Yeah, bitter. Thank you.
Thank you, Dr. Cooper.
I know in Hungarian, but in English it doesn't come. So, of these 4 tastes, only sweet is addictive. The other 3 are actually stay away from it.
Right.
Sweet give you the endorphins. They give you. I mean, I have a German Shepherd at home, which would actually, if I don't give him a piece of chocolate, he would. That dog. I sleep with that dog every night. If I don't give him a piece of chocolate, he would kill me.
Really?
Yeah, he's just that. He's so obsessed. Well, I don't give him. No, listen, I just have to kind of just move it in front of his nose. I wouldn't give him maybe sometimes he likes a little bit, but yeah, and he gets sick of it. But anyways, if it's a fruit, animals, they are waiting for the apple season because there are fallen apples they can satisfy for a few days. They're like drug addiction, like sugar addiction, but nature takes care of it. Bacteria gets to it by next day. It's practically vinegar.
Interesting.
So that's why actually biochemically nature controls everything that has sugar in it, because that's the strategy how trees get propagated. But if it would be available as a food source throughout the year, animals would have to adapt to that. There are a few birds that can actually eat nothing but plants or fruits, but they actually poop everywhere simply because they don't digest it. They just actually use the phytochemical, the fat part of even those fruits, and they actually get rid of the rest of them.
Here's where I need some good news from you, man. Would you say that a lower sugar fruit, such as my beloved wild, not domesticated, falsely sugarized berries, but wild blueberries that are lower in sugar and are wild, would be not as high in deuterium as like a GMO cantaloupe or something?
So look at it this way.
I love blueberries.
So here's what I can say. Therapeutically, if we were eating for a purpose, you wouldn't get to eat blueberries.
Okay.
Yeah, would not know what it is.
Starting today, I'm not
therapeutically. That's I mean, but you'll be able to deplete deuterium. That's the good thing about this. Even bad things are okay if you can deplete deuterium.
I see.
Right?
Okay.
Now, if these are wild blueberries grown locally,
Does Maine count as locally?
No, it doesn't. so that's the catch.
Yeah, because you are exposed to certain that's where Dr. Cruiser's research. I mean, I feel a lot of research. We actually very good friends. I mean, I really admire his research simply because he can position light and light source into this entire biochemical scenario. And if you lived in Boston or in that area and you have 4 seasons and you know what blueberry is and where to find it, you're welcome to eat it. Going to Rolf's in California, where this is not a natural inhabitant for this
you can't grow
you can't grow it here, is and you are exposed to different photon pressure, meaning that your fractionation in trees or in the fruits is different. What you eat is what you can accomplish simply, and what your body in the form of cholesterol can sense in the form of resonance, like where you live. It all comes together in a very complex, yet it's a very simple way. It's just you have to eat local, that you can grow, or you would know if you would live there like a few hundred years ago before commercialism was that common.
Right.
So my guideline is always just whatever grows in the garden, or just eat fat. That's
Right.
all.
Right.
Because the animals already ate what I supposed to eat as a supplement.
Got it.
So I just eat them because they already ate my supplements.
Yeah.
Got it.
It's Dr. Cruz's saying, my food already ate the supplements. So, and you can eat it, I guess, because it's low in sugar. It cannot be farmed. They have to collect it. That's why it's like somewhat expensive.
Yeah.
And with moderation, I think you can eat it. Sometimes I eat a few pieces, like maybe once a week if I feel like it, but it's really not my main food. I'm not obsessed with it. I can go without it.
It's cool.
Okay, cool. That's good. That's good.
After all that.
Yeah, no, it's good. I mean, I asked some people, does anyone have questions? And they're like, tell these guys they need to make a diagram of the foods that are in the green zone, the ones that are iffy in the yellow, and the ones that are like the never eat zone,
Well, if they send us an email, we'll send them what to eat, not to eat. We have that. So
cool. That'd be good.
Okay, we don't want to give you supplements. We don't want to recommend you food that you should eat. What you should eat is your natural biological instinct,
He's
and
tired.
that's fat and meat.
tough.
Right, okay.
The guy eats raw bacon. Okay.
Yeah. What? Are you serious?
He's dedicated.
Oh, yeah.
He's
son,
dead.
that's-
He's
Well, I
dedicated.
smoke.
He's dedicated.
It's smoked.
dude.
It's smoked.
It's
Smoked
smoked. It's
bacon.
smoked. But he's dedicated.
But I don't
Reminded
cook
me, I
it.
have some bacon from Del Campo that I need to cook up before it goes
Can I
bad.
take it with me? It's just
If you
I'm just kidding. Whatever. Yeah, I'm gonna look in the kitchen. So that you guys just keep talking. Okay.
The other thing I wanted to ask about then, so that the food thing, I mean, ultimately is fairly simple in terms of this depletion. Is like we want to be eating, if we're eating meat, we want to be eating grass-fed meats, high fat. We want to be avoiding complex carbohydrates, grains. All that shit is out. Gluten's out, not because it's gluten, but because it's high.
Gluten, lectin, these are high deuterium
Legumes
plant phytochemicals,
also.
Yep.
protein, sugars, you have to position or find out what is the deuterium content of that particle. Then you have a much better chance of
Right.
interpreting that, like what to expect.
So someone
from those
listening
kind
to
of
this could
routines.
effectively they can Google around and research a ketogenic diet, whether that be a plant-based one or a one including animal products, and just follow that, and they're pretty much in the
It's a
zone.
natural ketogenic diet. It's not Paleolithic ketogenic diet, because that would take 10 ppm off of
Okay.
the whole scenario. So you eat Paleolithic ketogenic diet, you have to go to a pharaoh's pyramid, find their beef jerky, and eat it from like few thousand years ago. Then you're closer to a Paleolithic diet. It's still not Paleolithic. It's Egyptian diet from the old times, but again, that might be higher by 5 ppm from the Paleolithic. So our phrase here is natural ketogenic diet.
Okay, got that. And then in terms of supplements here, and this is a tough one for me. If you guys saw in my kitchen cabinets, man, I mean, I got a little skinny ass cabinet with a couple cans of sardines. That's like my food cabinet. And then I have a giant double door cabinet of superfoods, some plant, actual plant materials. But there are some synthetic nootropics for, cognition, racetams. I take modafinil every once in a while. I mean, definitely synthetic white powders that come from clean labs in China.
That's an oxymoron by itself.
Well,
So they.
Yeah, I'm gonna take supplements as soon as I see a lion doing push-ups or doing running without any purpose, or taking supplements of any sort. Because I don't listen. I wouldn't need any of that. Be honest with you.
Well, here's the problem, though, is that I'm literally addicted to taking supplements.
Yeah, that's where it starts.
You know, if I'm really honest,
Yeah.
even if I was low deuterium, I had tons of energy, I felt amazing. I can't help but think, but if I took these pills,
It's hard.
Also, I would be like next level.
I know. So here's what we
Yeah,
always
because
say.
that's not how you optimize your nanomotors.
Yeah. So I mean, I and everybody goes through that. So what we always suggest is this: is you go off all of it, you build your deuterium levels down, you get your energy up, and then pick and choose the things you want to. And you know, it's just you're taking too many. Are there some that may help? I'm not saying they're not. I don't know what they would be right now, but if you've got your body running at 100%. Man, maybe the only thing I can see what supplements are good for, like you say, tropics and those kind of things, is once you have damage, right, and your cognition can't come back because you've lost that ability. I understand what those are for, right?
Well, I think I would qualify as that. I mean, I'm someone that used to smoke crack every day. You know what I mean? Like so, I've definitely done some damage, but I've also got an elevated level of deuterium. But I am, you know, when it comes to supplementation, I am mindful that I do a lot of research into the sourcing, and
but it's not sourcing. It's not.
I do prefer ones that are derived from plants.
No.
Yeah, let me give you a very good example. Have you watch Formula One car race?
I'm familiar with what it is.
Yeah, they all have the same size of engine and they carry all the same gasoline. Then it's the driver who decides the game. So your supplements are really unnecessary to optimize your ATP synthase nanomotors. What powers your system? It's just practically you can eat the same gasoline or you can eat the same fuel that our ancestors did. And back then there were no supplements. Trust me. And that's how human race evolved. So when it comes to your own physical performance, it's practically optimizing these nanomotors. The only way you can optimize them is with low deuterium. There's no supplement can optimize a nanomotor that is spinning in your system. It only needs hydrogen and it needs oxygen from air and hydrogen from food. No supplements can do this better than your natural fat source natural diet, ketogenic natural source diet. Now, what you do and what you are scared of doing and how much exercise you do and what do you use this nanomotor for? You can actually race it for speed. You can actually race it for strength. You can actually race it for jumps. You can actually do many different things, you know. But they all operate with the same principles. They burn gasoline. What you add to this particular mechanical complexity of your system is practically what you want to do with it. Mm-hmm. But to optimize it is nothing but eat ketogenic diet. No supplements are necessary because everything is in there and you just need these nanomotors to spin very efficiently.
And like I said, I mean, the supplements, so yes, that's what Laszlo's 100% right. Now, if you have damages in there, then that's where supplementation with the right supplement makes sense, right?
Now, if you have a deficiency syndrome,
there we go.
Again, if you have an underlying medical condition, you can't eat, you have a deficiency syndrome, then you have to supplement, then you have to use a supplement. But as long as you are able to optimize your nanomotors through food, supplements cannot really enhance the ability. You know, supplements are helpful to overcome physical limitations, like you don't feel that tired or you're more in a euphoric state. You know, that's what the use of these drugs are, but they are not improving performance simply by their biological potentials. And be honest, sportsmen nowadays on natural ketogenic diets, they do a lot better than people who do sports on supplements.
When it comes to someone taking supplements, then if they elected to do that because there was damage or there's a deficiency or something like that, or they're just like me and they're just addicted and can't stop, I'm assuming that something made from a plant is going to be lower in deuterium than just a synthetic white powder that's a synthesis of something?
Not necessarily.
Not necessarily.
Again, the industrial process takes them out of their chemical environment, so they work differently than in their natural source or chemical environment. And when you chemically generate like clean supplements or purify these products or dry them or you anything to them chemically, it may change the composition and the deuterium content of some of those natural. And honestly, I don't really know what industrial processes they use.
Right. How they do the extraction.
Yeah,
I don't trust them.
Yeah, I mean,
be honest.
the synthetic one. So in general, I would say yes. In general, it was like Laszlo saying, and I would guess that Whole Foods and things are better. But the process, we're actually working with a couple of companies now, trying to get them to give us samples and say,
Cool.
let's do these, because that is the question. They need to step up and say, what is the deuterium levels in these things? But
well, I've already, since I met you guys, I already emailed a couple companies that I get my supplements from, and I said, do you test the deuterium levels? Where are the actual nutrients derived from, et cetera? And you know, a couple of them, you know, the B vitamins can be made through a fermentation process, you know, or they can be made in a lab. So there's, you know, it's very nuanced, but something that I think is cool about what you guys are doing is that as companies that elect to manufacture these types of products and things like that will be able to start actually integrating the low deuterium process or testing of their products and use that in their marketing. So at least someone knows if they elect
What they are using now in
They're doing it
marketing
now?
deuterium content. Yeah,
That's
it's
cool.
yeah.
I
We
can't
no
wait for
well, yes indeed. Yeah, now there are even IPOs, you know, out
awesome.
there who actually at least they characterize their product based on deuterium content. It's not necessarily sufficient as far as deuterium depletion goes, and obviously the judge is biology of this, so we don't, you know, judge these products simply because of deuterium content. We think that biology or biological systems operate at lower levels.
Got it.
But their supplements are cool. I mean, it's like, again, one of the big things that we always really like. One of the biggest supplements out there, the protein powders and things people put in. You know, people don't often think about that being a big ass supplement. You know,
Right,
and
it
really
is,
is. And so, if it's not from a grass-fed cow, wow, that's interesting.
Yeah.
That's interesting.
Especially if that cow was grown on
Now
GMO
going back
soy and
going
corn,
back
you
to
know.
the camel, if you actually in Egypt, if you falsify camel milk or even urine, they use it as medicine. It's punishable by death.
Damn.
Yeah.
Wow, they don't play.
So
over there.
they don't listen again. The camel with its deuterium depleting potential is a huge health source and transportation source for countries with thousands and thousands of years of history of learning and doing.
That's
this
interesting
particular.
because the camel milk is this kind of emerging trend in the health scene.
Oh, yeah.
And
yeah.
I was researching formula alternatives for women that can't lactate, and the end of my research ended me up as the best alternative being camel milk.
It is.
You agree?
Oh yeah, it's fantastic.
Wow.
You know, again, what scares me though, is if they're going to get these animals over here
And
sort of
start
doing this
feeding them with
grain.
grain.
Yeah.
That's the
Yeah.
scary.
Well,
part.
the camel won't eat it.
Yeah.
though.
Well,
Yeah.
if they
It
domesticate
cannot
them,
be.
so-
Did they? I
What
don't
the
know.
hell
Yeah,
does
we
camel
worry
eat
about
in
that.
the desert?
Cactus.
Oh,
Yeah, you said
cactus.
that. That's
And that's what
Cactus
it is, man.
and
It's-
bush and
it's
whatever, you
amazing.
know, just
Amazing.
cactus. Yeah,
That's
just
so
cactus.
crazy.
It's-
All right. Okay. So we got the food, we got the water, we got the supplements. I swear to God, I'm gonna wrap it up. But there's a couple things that I just got to check on, and we can whiz through these relatively quickly and wrap it up. I know on your site you have an affiliation with my friends over at Juve that make the red light therapy devices. How does red light therapy play into the deuterium story?
It's very, very cool. And again, shout out to Jack, because he's giving us our shout outs for deuterium. We'll give it back to him for photon and lights. And so really what happens in this case is red light. Let's make it even simple. It when the deuterium is working, your deuterium levels are low, right? What red light is able to do is essentially thin out that liquid. So now the nanomotors can even go faster. That's the easiest way of setting it. Goes to a cytochrome. It is fantastic. We're great believers, and we're going to start doing a project with the people at Juve. We're going to study.
Great. They're going to be up here in a couple weeks.
At this table. We're on the same page. It's awesome.
Yeah, I like those guys.
Now, the simple answer is that
I have it in the other room now.
red light with 680 is practically resonate with the hydrogen bond. So when red light hits a water molecule, or to that extent a cholesterol molecule, it starts resonating its hydrogen. It communicates energy to it. So these molecules get down to the mitochondria and the nanomotors, and they are actually able to make water more viscous. They communicate energy. The red light that's how actually photosynthesis works. That's why hydrogen breaks off of the oxygen during photosynthesis, because of the red light in the spectra.
In the sun.
In the spectrum. Well, and the cosmic background radiation has a spectra which is in the red zone. So it's not light. Sun is not the only light source.
Really?
Oh yeah. There's a cosmic background. I didn't want to talk about the Bible or the Torah simply because
we talk about
because actually
how much time do you have left?
that would take us a little bit far, but actually there is like so many mention. I mean, the whole Torah, if you read it from a biochemist or a physicist point of view, it's nothing but deuterium depletion, fractionation.
Wow.
And it's true of the kosher diet. It's true of getting water from the rock. It's true of the fountain of youth. Everything is sinking in the water, so it's deuterium depleted, low viscosity water. So you can identify in these old scriptures. I'm not here for religion. It's just practically old scriptures. If you read them as a scientist, you're going to find many principles that we talked about here today.
Wow, that's really neat. Let there be light. So red light, we're on board with that. And then what about in terms of just one thing I'm a huge fan of is just getting as much of my naked body as legal into the sun. Like, I'm really into being grounded. I know the other day you were talking about
same thing.
How does the sunlight, same kind of
same
deal?
thing. Yeah, your body, if you really think about it, I've now come completely 180 degrees. And that is, really think of your body's ability. It eats everything. It eats everything, and it turns it into something, right? That's what it's doing, including bad energy and bad thoughts and good thoughts. And what I'm now thinking, it starts to resonate, and it resonates through these hydrogen bonds, just like everything else, and it determines what energy you have. So I believe that all these things are related, everything, because ultimately that's what we are. We're energy. When we die, we're energy. That's it. That's why when you look at someone who's dead, you go, oh, God, Luke's dead. No, your body's still right there. No, it means your energy's gone out of that body. That's what death means.
Your synthase, ATP synthase nanomotor stopped.
Yeah, that's it. This is interesting because you should actually talk. That really is the definition of death. It's not break, because once they all stop, you can't start them back up.
You can't start a nanomotor. It has to get it spinning from already spinning nanomotors.
Isn't that crazy?
When it comes to the sun and vitamin D, what I'm assuming here is that the precursor for vitamin D is deuterium rich, and so you can't produce enough of it now?
Go ahead.
Yeah, go ahead.
That's the same thing. So yes, you can't break cholesterol, right? Therefore, you can't make the precursors.
Yeah.
And not only, even an interesting thing, and you can't put the sulfonation on. That's the other thing that goes. The sulfate. He's going to even go further. The sulfonation, all those molecules to make them water soluble. So now you're even getting a whole bunch of stuff, vitamin D and stuff in your. That's not good for you. It's not vitamin D. It's water-soluble vitamin D.
Right.
And that's, again, it's not me. I can't, I stint it. I mean, that's great. Great work. But that's the way this stuff works. So with this deuterium in it, now you got the wrong friggin' molecule that screws you up.
Wow.
It's like your chorus and your tuning key. You know, the cholesterol, it practically resonates. Although it has 27 carbons and they have hydrogens in various positions, and your red light resonates them all. Mm-hmm. It's like your tuning key. When you ping it and you give it hand by hand, it resonates for a while. And it tunes, cholesterol tunes your body to the outside light pressure and light spectra. And Dr. Cruz is right. Your body is mostly a photosensor. That's how you function. That's how you make your metabolic water more viscous. This is how you interact with your food source practically, what to eat. And this is how your body knows what to prepare for, practically how much oxygen you need, how much hemoglobin you need. It's practically just, if you move to a different elevation, there's less hydrogen there. Practically, there's more hydrogen compared to deuterium. So you can actually live with a lower oxygen tension, and you just adjust or adapt by your hemoglobin to this particular, because oxygen has to be carried as much as protons are available. So as what this fine tuning is done by sunlight and your eyes, your skin, and so on. So these systems are very interconnected. These systems are very sensitive, and these systems are very basic and fundamental to actually guide your life. Simply to stay free of disease, simply just have to be below a certain biological threshold. And even though you have predisposition factors like genes or whatever, I'm not big on genes, but I don't believe in that stuff. But actually, whatever they claim nowadays as a predisposition or as a risk factor, below 130 ppm or 120, or let's say below even 115, back to the caveman's time, you practically would not experience those clinical symptoms simply because there is no deuterium for them.
And like you said, and then getting grounding and all these other things are just part of this.
Right.
They're all important.
And what about, you guys have any input on or opinion on infrared saunas?
So infrared saunas create heat. And heat is a great thing that makes things move. There we go.
Okay.
And it does, they have healing. Yes, they have definitely healing things that go with it and all these. But it's not
but again, they
it's
jump
not
into the
same.
cold water after it.
Yeah.
So
Well,
again,
that's the next one, is the ice baths and the
love
cold
it.
yeah. So again, if it's 100 years of natural health tactic, let's say up in the north, if it is, and if it has a traditional role and respect, and it's true of all natural acupuncture, kind of natural, integrative medicine, that's where it comes together eventually to regulate this deuterium content, or how you can deplete deuterium through various processes like infrared sauna or whatever else there is out there in various geographical regions with less photon pressure and so on. Those can all be positioned. I'm not sure if it's good here in California, but I'm sure it's good in Finland or in Scandinavia. So truthfully, these are all part of cultures and the human healing process. How to position them and how to integrate them to society is the question of how much we understand how they work.
Got it. And what about hyperbaric? You mentioned putting the dogs in the hyperbaric. Are you guys fans of that?
It's the same thing. Again, dogs, yes. But once we understand, it's just oxygen, right? Mm-hmm. And it's being able to get the oxygen into your tissue. Hyperbaric oxygens can do that. However, what now we understand is we can retrain your body to breathe, and it does it better than hyperbaric oxygen, because you can only go in a hyperbaric oxygen chamber so many times before it becomes dangerous, or it actually has the opposite effect and can hurt you.
Oh, damn.
Right?
Okay.
So really, we can train you to breathe. Most people, especially with disease, and as we get older, we hyperventilate. We breathe too many times per minute, and that it's contrary to what you would think. What it does is that makes the hemoglobin hold on to oxygen because your body thinks you have enough oxygen, and that's the opposite of what you want. So what we do is we've invented a mask to where the person actually would wear the mask and breathing in part of, with these exercises, they breathe in part of the CO2 in the mask. Actually, you have a mask, I think, right? And you would go down, then you see a little piece of carbon dioxide now gets into the blood, and that tells the hemoglobin to release oxygen to the tissue. That's what you want. Wow. That's safe. And that's really what, and if more oxygen, right, it's going to deplete the deuterium. That's what you want. That's what it's
awesome. For. And is there any place for ozone IV treatments?
So, yes. Yeah, again, it's just another way to get to the end. But at the same time, deplete your deuterium first.
Okay.
And then use all the. That's. I mean,
yeah, usually, yeah. If you have a hemoglobin and if you don't have sufficient oxygen, and you can name a number of mechanisms that can lead to it, all these approaches might be beneficial to somebody who is deficient. Again, just like when we talked about supplements, as long as you're below 130 ppm, at least what you're exposed to. And then if you eat a normal, natural ketogenic diet and you are not deficient of, if you don't have an underlying disease condition, you don't need anything other than just practically just these very basic elements.
So if, in other words, like if you were trying to knock down a systemic viral load using the ozone IV, that step might not even be necessary because you have the metabolic energy power
again, because
to knock it back on your own.
You don't have enough protons to make him water. You don't have enough hemoglobin to carry oxygen to the tissues. You may not have enough exercise to utilize that oxygen for. So just because you give somebody something that you think they are deficient of, it does not mean that their physiological system actually need it or have not adapted to a different kind of environment or situation, which is oxygen tension or partial pressure. So practically you need to, be kind of just alert of all these biochemistries.
Got it. All right. Well, hot damn, guys, I think we did it. I mean, if we didn't cover it here, I don't know what we're going to do. I think the bottom line is we can send our friends, our listeners to ddcenters.com. There, they can get themselves into testing. They can get their test results. They can implement a protocol with the depleted water, following the diet. After a period of time, get tested again. And this is something that's very attainable and, for the most part, affordable. And when I mentioned the water being expensive, I mean, if someone's thinking about it as a bottle of water, a case of water, I would say it's hella expensive. However, I'm just going to say for myself, because I'm someone that invests in my own health, like the dollar amount doesn't matter to me when it comes to being well. But I have to say, people always bitch to me about how much my supplements cost and grass-fed meat and all this. Have you ever priced out chemotherapy, dialysis? I mean, you want to talk about money? You start getting sick. My mom.
Yeah, and again, I mean, it's just, and again,
so,
if you drink a bottle up, if you don't have to drink it all. If you drink a glass or you use it for coffee and your soup, it's not expensive. It's not any more expensive than eating a box of cereal a day. It's not. It's actually cheaper. Cool. Meaning that you don't have to eat, you don't have to have 3 meals a day. 1 meal is enough, but eat some fatty meat stuff.
Right. I was just trying to think. When's the last time I bought cereal? How much does cereal cost? I was computing. I think it was like in the 80s probably.
Yeah, but you don't. But many people do. It's actually cheaper to actually buy expensive water and drink as much as you need, just a little bit of it.
So, it like I even go further. You can dilute this to such a point to where it's still equal wellness water, quote, quote, is cheaper than Fuji.
Right.
But people, they line up to get, electrolyte water and vitamin water, but they're not helping. So this is the same price. So what is the question?
Cool. Okay,
Right?
good. All right, good to know.
Yeah, because people have this mentality, oh, this is good for me, I have to eat it all. No, you don't. And actually, we took something out of this water, so you just have to make it integrated into your routine and be aware of the fact that the best water source is your food.
Got it.
It's
Eating
not.
those
It's
good
not in the
fats.
bottle. Eating the good fat, having a good fatty meal, and allowing your antidiuretic hormone to kick in, and deal with your thirst for a few minutes and wait till it goes away on its own, so your antidiuretic hormone can adapt to it. That's cost effective.
Got it.
You don't have to drink it all and pee it out. You just have to drink very little of it and just deplete deuterium in the
So
meantime.
the therapeutic dose of the depleted water is not that much. You don't have to drink a gallon.
No. And your therapeutic meal is only once a day.
Yeah.
Got it.
And it's really just dependent on you. And that's why this is truly individualized medicine. We hate that word usually, but in this case, it's real because it's all about what you can deplete. And we get to that point. That's where we come up with the protocols for you. And it's up to you to decide how to get there. Some people don't want to make changes in their diet. Fine. Then drink water, do this. I don't want to exercise. Okay, then do this, and this.
I know that I really don't believe the pH of water matters at all. I did fall for the alkaline. I won't say I never. I fell for it for a while until I did more research. I'm just curious, what's the pH of depleted water? Does it end up being more acidic or alkaline? Again, I don't think it matters at all. I'm just curious.
Yeah, so again, we have to kind of go back to some physics or biochemistry, which I don't want to detail. But okay, so there's hydrogen and deuterium have different, what we call a dissociation coefficient, meaning that how easy they get separated from their atomic bonds. That's just practically what it is. Deuterium has 3 times lower constant, meaning that it's 3 times harder to remove or move it, or 8 to 10 times harder to move it from a chemical bond. Now, deuterium-loaded water is more alkaline, simply because there's less free protons or hydrogens in that water. So alkaline water, I don't know what it is exactly, but it's probably heavy water.
Yeah.
So if there's anything I would stay away from is actually alkaline water, because actually heavy water is more alkaline
Heavy
than
water meaning it has
and that's
high
actually, and you
deuterium.
know why this is a good question? Because the very first chemical carcinogenesis model determined that actually alkaline pH is related with cancer or cell transformation, and it's because of heavy deuterium. So they didn't talk about deuterium, but that's what it is. So physical chemical properties of water is very much dependent on deuterium and proton ratios, and heavy water is more on the alkaline end, and light water is more acidic. It doesn't mean that it's actually acid, but it's in that physiological range, which is around 7.4 the pH. When it goes to like physiological ranges, you want to be more, if you drink a little bit of water, again, I'm not recommending drink a lot of water, but as much as you need, that has to be light water and more acidic.
Interesting. Yeah, well, the thing that got me off of the whole debate with the alkaline water is when I started doing breath work.
There you go.
You could do breath work.
Yep.
You can go pee on a strip and be acidic, and then go do 12, 15 minutes of breath work, and you can be alkaline as hell.
Yeah, that's all it is.
After that, I was
That's
like,
it,
oh, it's not.
Yeah, your body has already so strict and built a mechanism to regulate pH. And it's, again, like your temperature, your deuterium level, and your pH is always the same. Your temperature is 36.5 Celsius. Your pH is like 7.42 if in your plasma, and your deuterium level is supposed to be 130 or below.
Cool. Good stuff.
In your saliva, in your breath, in your cells, it's probably even lower, much lower than that.
Wow, this is insane. My mind's blown. I've learned so much from you guys today. I got one closing question for you. for each of you, I want to know 3 teachers or teachings in your life that have influenced you and your work.
So mine is definitely Albert Szent-Györgyi, who my grandparents knew. He's the 1938 Nobel Prize winner of physiology and medicine because of the cycle that they clarify with the biological oxidation process, and because of the deuterium depleted water recycling process in mitochondria. I learned a lot from my anatomy professor in medical school, who was a very devoted teacher. And my biggest teacher was my father and my parents, who actually taught me how to be a honest scientist and how to pursue unknown areas and how to interact with patients, and their problem is their disease, so there's nothing else to talk about. So to me, it's just always medicine and science as far as great teaching. There are others that I don't want to leave out anybody, so I learn from my teachers, my friends, my colleagues. So it's just a very broad group of people in their education, in their experience, and their expertise, and we do respect everybody's own pursuit, yet ours is related to this deuterium chemistry, and we would like this to be as broad of a knowledge as possible.
Awesome, thank you.
That's pretty cool, man. You put me in a... I might have to follow you,
Say
dude.
something, man.
What's up with
I'm
that?
your biggest teacher, so say something. Just
I like to thank Laszlo for everything. So I'm going to go the
listen.
opposite.
You don't
Okay.
have listen.
I'll pay you later. I'm going to go the opposite way, or not opposite way. I think it's very interesting because when I think about myself, it's all about how I got here and why I'm even here, because that shouldn't be. And I would go back to, and it's going to sound almost trite, Martin Luther King, for really teaching the lessons of what you could be and the ability to look at anybody and understand the character of who they are and that everybody's important. My first grade teacher.
Shockingly, that's the first time MLK has been on someone's top 3.
Yeah, well, I'm gonna give even another one.
All right,
You're never gonna Miss Wilson, my first grade teacher, who told me it was okay to be black and I could be first president of the United States. And she was wrong on the president part. I don't want to do that anymore. Those two, and then the third one, I'm going for the trifecta, black trifecta. So I'm sure that would be Malcolm X. And I really, by any means necessary. And I run my life that way, and that's the way we run our place. And it comes us right back full circle to what we go with our 360-degree, everything out, deuterium by any means necessary. So that's for me.
That's awesome, man.
And then, of course, Dr. Boros.
Thank you.
Which,
and
Thank you.
Are any other websites or anywhere you want to lead anyone other than ddcenters.com?
No, if you go to ddcenters.com, you can learn about everything there. Our learning center is fantastic. You can hit our Facebook page, our Twitter and Instagram. They're all connected. Our own pages for myself, Dr. Boros, and Dr. Cooper. The Ketopractor. That's Dr. Cooper. Shout out to the Ketopractor. So,
Well, we do have to mention a colleague of ours, Dr. Gabor Shomiai, whose work in the deuterium depletion and the clarification of how deuterium determines cell growth are fundamental. He has been a relentless pursuing person of deuterium depletion of many different biological systems and models. We have been working closely together, and my contribution is positioning his deuterium depletion and deuterium depleted water with metabolism and with mitochondrial water production. That's our main contribution. So we linked the mechanism to the living oxygen-consuming, water-producing mitochondria. That is the central mechanism that we clarified based on his work.
Yeah, thanks for that, because I almost forgot. He is the fourth He's part of the four.
That's cool.
The four horsemen.
That's cool.
There you go.
And we thank our clinics, Liz and Radu and Esther and whoever else contributed, simply because we need people who are our colleagues and helpers.
That's cool. Well, thank you for giving those guys a shout out. And we've got Dr. Ann Cooper over here who's been sitting here for 3.5 hours, probably going, I've heard all this before, guys. I swear I should have given Ann a laptop. So we're gonna figure out a way to get her on one of these mics too and get her perspective on this. But I want to thank you guys so much for joining me today, and I'll go ahead and stop with the audio now and until we meet again.
Oh, fantastic. Thank you.
Later.